Good morning, everyone. Am I audible? Please let me know in the chat box. Yeah, thank you, guys. So, welcome back to the Python Advanced Week 3 Day 2. So, yeah. So, we'll start with yesterday's leftover agendas. So, yeah, guys, without wasting any time, so let's continue the session. Hello, Shikhar.
Hello, Harish.
Yeah, good morning to you. Now, over to you, Shikhar.
Okay. Okay, hello, everyone. Welcome back to another session. Just a minute. Okay, so as you can see in front of you, the topic for today is going to be something called as data visualization. Now, what is data visualization? What we do in that, we are going to talk about it in a proper detail. Okay. Now, before talking about this, I want to give you a basic idea about why we do data visualization and where it comes into picture. Okay, so till this point, we have been talking about a lot of things. Yesterday also we discussed about the concept of regular expressions and date time. Before that, we have discussed about NumPy, pandas, and the basic Python fundamental concepts. Now, where does visualization come into picture? If you're talking about data science, when are we going to talk about data visualization and why exactly we do that? So the process of data visualization comes after the data manipulation. Data manipulation is the step number one. Okay, data manipulation is the step number one. After the data manipulation, the concept of data visualization comes in. Okay, so when you have manipulated your data means a data has been given to you and you changed it according to your thoughts and whatever task has been given to you. Accordingly, you change the data. So basically in data manipulation, you will be adding some extra columns, deleting unnecessary columns, or removing the missing values which are there. Those are the things are done in manipulation. After manipulation, once your data is clean and once you have added or deleted the information according to your task which you have to perform, then you move forward to data visualization. What we do in data visualization? Data visualization is a way to understand the behavior of the data. And second, it helps us understand the trends, patterns, and relationships in the data. First things, it helps us understand the behavior of the data. Behavior of the data means, is my data normally distributed? Is my data having any outliers or not? Or what sort of values, in what range of values most of the data points are concentrated? And the relationships, the trends. So do we have a positive relationship between this and this data? Or trend, some sort of trend? Or you can say relationship. Do we have a positive relationship, negative relationship? What kind of relationships are there? For understanding that, we have the data visualization concept. Now, after manipulation, we'll do data visualization and we try to understand the data in more detail. Now, visualization came into picture to understand the data in a visual format, because when you look at the picture, this is a broad view of the picture. Got it? Now, if suppose I've given you a CSV file where a lot of columns are there, sales column is there, and those product category column is there, different columns are there. Now, you can look at the data and try to find out some information, or you can make a plot of that, and that figure is going to tell you in easy manner what is the information stored there in a very easy and simple to understand manner. Now, when you make visualizations, in visualizations, you don't go into details of every value, that what is this value, what is this value. You don't have to look in the details. You just have to look from a very broad perspective. Okay, broad perspective, like if you talk about a bar chart, there's a bar chart. What is a bar chart now? Bar chart is going to have buildings like this. Now, suppose, what is these buildings? Let's suppose we have elections coming in. And in the elections, different political parties are there and they are getting their votes. And we are trying to analyze which party is going to win by what information we know as of now. Right? So what we can do here, we can take the number of votes that a party has got, we can put that into building format. Now you don't have to see that how much value is this of the building, how much value of the building, how much value of the building. Just you can say that if it is political party 1, political party 2, and political party 3. The building which is highest for whichever category, for whichever value, that is the most popular category. And whichever has the smallest building, that is the least popular, and that is what we need to understand. So we don't go into details of see how big this building is, what is the value. We don't go into those details, basically. What we are trying to understand is an overview, a bigger picture of what my data is trying to tell me. That is the advantage of using data visualizations, that you don't have to worry about the small details of that. You can focus on the bigger picture and you can understand the concept very properly. That is the data visualization. Okay, now, in data visualization, we are going to talk about different type of plot. Okay, now see. So whatever information we are going to have is going to be on this X and Y axis format. We'll look into it more in detail. But the first package we are going to talk about for data visualization is going to be Matplotlib, the very first package. And it is the oldest package which was created for visualization purpose in Python or in data science, data analysis, you can say, oldest package. Now we have very interesting tools like Tableau and Power BI. Tableau and Power BI. These are the tools which are specifically created for visualization purpose. These are special tools, like Excel is a tool for data handling. Tableau and Power BI are tools to create visualizations, much better visualization that we will be using with Python. But Python gives you what? Python gives you a way to make those visualizations and to understand the data quickly. If you want to make powerful visualizations, you can go to these tools and you can increase the amount of information that you can see there. But Python gives you enough to understand anything about the data. Okay, Matplotlib we are going to do. If you have to install Matplotlib, you're going to do like that. But if you're using Colab and Jupyter Notebook, it will be already installed there. Now, there are some common type of plots. You would see that some plot is like this. One plot is like this. This plot, this plot, this plot, this plot. Different variations are there, which are available to us that I can use. There is a pie chart, there is a bar chart, there is a histogram, there is a scatter plot, line chart, box plot, different types. Now, why do you think these many options are there for us? Or the second question I can ask is, do you think that I can take just any data and make any plot on that? If suppose a data I have given to you, a particular column of the data frame I have given to you, can you just make directly any type of plot on that, randomly, not even thinking about what is the information? No. And we should not be doing that. Maybe it will create a plot, but it will not represent the information that you're looking at. So when you're talking about a specific type of data, there is a specific type of plot suited best for that. Okay, and we will see just about that. I'll give you an idea about when to use a line plot, on what data we use pie chart and bar chart. So the main thing in visualization is to understand, is to remember that which data is suited for which type of plot. That is one thing you need to remember. Next. We have these common plots. Now, there are some functions that we are going to see with Python, and let's see this in more detail. So see, in Jupyter Notebook, if you are doing this, I have created a data visualization folder where I have saved some files. I will share these files with you, but I want that you first focus on understanding the concept that I'm explaining to you. Later, you can do the practice. Okay, because the code is going to be little lengthy. So if you don't write very fast, if you don't type very fast, so you can do this later. Don't be confused about writing this and then understanding this, then it won't be very good for you. You won't be able to understand the concept. You won't be able to ask the doubts. So first I want you focus on the concept. Later I'll share the file with you. You can go through that. Okay, now, for those who are using a Google Colab, the way you have uploaded the file for pandas, if you remember, in files.upload part that you've done, you can upload these files like that. Yes, we have these files: market fact, marketing data, mouse data.csv. Maybe this one you don't have, the second one, but the first and the third one you would have. I just shared it once again. Now I'm going to make one new notebook file for this. And we will be talking about data visualization. Now, if I have to work with data visualization, the first package, the first library, as I said, is going to be matplotlib. So to import matplotlib, you need to write import matplotlib.pyplot as PLT. PLT is the short name, PLT is the alias name, which is given to this particular module, particular package. I'll read this and then I will have to import pandas also, because we are going to read some files. These are the two packages. Now, before moving forward to understand those plots, those functions which are given to us, we have to talk about the basics of plotting. Some basics of plotting, which means that when you look at the information, and to represent this information, I have, let's suppose one data I've taken. See, pyplot is a module. This matplotlib is a package. Package is a bigger thing. In package, the pyplot is one module. Apart from this, there are other modules also. So from matplotlib, we are using one module for our purpose, .pyplot. Okay, matplotlib has another modules also. So matplotlib is a package and pyplot is a module inside that. Got it? And from this, we are going to use some functions that will help us make the plots. Now, see. So suppose I take two information. There's a company who is spending some marketing budget. There's a company who's spending some marketing budget. Then there is a that company is getting some revenue. When the company spends something for marketing, their sales will increase, their products will be sold more, and they are going to earn more profit, more revenue. So suppose these two information is given to us. Now what will happen? You're going to either see this kind of plot or you're going to see this type of plot. Some type of plot like this you're going to see. Now, what does this represent? This represents that there is a positive relationship. There's a positive relationship between this and this. So we can say that when we are increasing the marketing budget, suppose I've taken this as the marketing budget. So this much was the revenue. If I increase the marketing budget from this amount to this amount, I'm increasing the marketing budget. Revenue also increasing, going upwards. So on the x-axis, whatever numbers are there, they increase on this side. The values increase when you go right side. In the revenue column, the values increase as we go top, like that. So as you can see, as I have increased the value on the right side, then the revenue is also increasing. That is what linear relationship is. Okay, that is what linear relationship is. Not hypothetically, whenever you are going to see this kind of line, it is telling you that relationship. Now, when you see the plot, there will be some values that you will have on this plot. There will be some values here, some numbers here. Okay, some numbers here. So let us suppose I am going to write some numbers like 25, 50, 75K, 100, 125, 150, and 175. Suppose this. On the revenue side, I can say 1, 1.5, 2, 2.5, 3, 3.5, 4. Now have a look at it. Now, what is this? In the marketing budget, I'm talking about, let's say, a company has spent 25,000 rupees or $25,000. Anything you can understand, like $25,000, $50,000, $75,000. Like this, the amount is being spent by a company. Then according to that, they are getting the revenue. So when a company has spent 25,000 rupees, so they got a revenue of 1 lakh. 50,000 rupees, they got a revenue of 1.5 lakh. 75,000 rupees, they got a revenue of 2 lakh. Like that, they are getting some amount, some revenue on the basis of whatever they are spending. Now, the thing I want to talk about is how do you get these values? And how do you decide what will be the difference between two particular values? I've taken 0, 25, 50, 75, 100, 125. These numbers I've taken on x-axis. And here I've taken numbers on y-axis. How do you decide that? This is going to be decided from the data. This is going to be decided from the data. Let's say I have a column called as a marketing budget. Then I have a column called as a revenue. Marketing budget and the revenue. Now, whatever information is there in this column, we are representing that here. And whatever information is there, we are representing that here. Now, these numbers 0, 25, 50, 75, 100, 125, these numbers are decided according to the minimum and the maximum value in this column. So suppose in the marketing budget column, you are seeing that there's a minimum value which is 25K and the maximum value is 175K. Now you have to make a plot to represent these minimum and maximum. Okay, so when you look at this minimum and this maximum, you have to make the range, you have to put the numbers in such a way that you can fit all the numbers and there is an equal spacing between them. Now, suppose I have taken a 5,000 difference, 25, 30, 35, 40, 45. Will I be able to represent all the numbers on x-axis if I take 5,000 difference? It won't be possible, right? Because I have a certain amount of space only, and I cannot make my axis too long to represent the numbers like 25, 30, 35, 40, 45, going till 175. Okay, that won't be possible. So we need to take a space in such a way that we are able to fit the numbers and they have equal spacing between them. Okay, so this space between two numbers and what range will be going, that is decided from the minimum and maximum value of that column. Similarly, in the revenue column, the numbers are like from 0 to 4. There are numbers like that. So that is why we have put the numbers in this format. And the spacing between 2 points are according to the minimum in that column and the maximum in that column. Got it? These are the values. And this is how we decide what values will be on x-axis, what values will be on y-axis. This is the deciding factor, always from the data. So whenever you look at these x-axis and y-axis value, don't think that they are just randomly put some number someone has taken and they have just represented that. No, they look at always the minimum and maximum value of that data. And according to that, you represent that information here. Always happens like that. So this is the basic idea of the plotting. In the plotting, you will have a figure like that. This is called my x-axis. This is called my y-axis. You will have like this. There will be some numbers on x-axis, y-axis. There is a label on x-axis, on y-axis. Label means this name. What is the value on x-axis? What is the value on y-axis? Labels will be there. And then some type of plot will be there in the middle of that. Either it will be a bar chart, a histogram, or a line chart, or a scatter plot. Some sort of plot will be there. These are the basics. So let's move forward and let's try to create these type of plots with the code. That is what we mainly want to do. Suppose I'm going to make my make our first plot, and for that I'm just going to take a dummy data for now, a simple NumPy generated data, and then we will look at the columns also. Okay, look at the columns also. Ravina, I'll show you how to decide which values to be taken on X and Y. Everywhere, wherever it is coming, I'll tell you that. Suppose we have X. Now I need to take something for X. I will use an np.linspace function for that, where I'll say, let's suppose I have a value from 5 to 100, and then 25 data points are there. In Y, I take np.linspace. I'll take 10 to 1000, and then 25 data points here. What I've just done, I have created two variables, X and Y. Both are arrays. And both the arrays have 25 values given to us. Both the arrays, 25. Now, what is this saying, 5 to 100? It means that 25 values are there. It is in the range of 5 to 100. And this 25 values which is there is in the range of 10 to 1000. Okay, 10 to 1000. Yes. 10 to 1000. Now, what are we going to do with this data? We are going to plot it. Okay, once I've got my X and Y, we are going to plot it. How would we plot that information? So to plot that information, a very common function that we have is plt.plot. PLT is the name of the package, and plot is the name of the function which you are taking from that package. What you need to do now, you just need to say X comma Y, that plot this X, plot this Y. And then in the next line, you have to say plt.show. plt.show. plt.show is to display the graph. Display the graph. Run it. If you want to look at the X and Y values, you can look at it. X is there and Y is there. So in X, the values are from 5 to 100, and total 25 data points are there from 5 to 100. And here we have the values from 10 to 1000, 25 data points are there also. What are we plotting now? We are plotting these two. The first value and the first value of X, first value of Y, this is what we are plotting. So if you look at it, there is a 5 here on the X-axis, and then there is a 10 here related to that on the Y-axis. And this is the first point that is getting plotted. The second point that is getting plotted is 8.95, 51.25. So somewhere 8.95 and then 51.25. Then 12.91, 92.5. So there is a 12.91, 92.5, like that. Okay. So these are the things which we are creating. These are the X and Y values. And according to these X and Y values, we are plotting it. Now, this is our very first plot. Yes, that is what I said, that the numbers on the X-axis, that is what I was explaining a few minutes ago. That who is deciding these numbers on X-axis and Y-axis? So it is deciding on the basis of this minimum and this maximum. In X, what is the minimum and maximum? 5 to 100. Okay. Then we have 10 to 1000. Minimum is 10, maximum is 1000. So now if you look at it, it is trying to create from 0 to 1000 and 0 to 100. And this is the basis. The minimum and maximum is the basis to create those values. Now it has taken the difference, 2020 difference, it has taken itself, understanding how can I plot these numbers. That difference it will take automatically. You don't have to do anything. You don't have to change anything. Okay, now the plot is created. Just now explained, Sujata, 25 is the number of data points. Lens space you have already talked about. That is what I'm not going into detail of that. Now, the plot is created. When the plot is created, as you can see that it is incomplete. We don't have the information that what is the information on x-axis, what is on y-axis. We don't have that information. Labels are not there. What is the title of the plot? That is not there. Those are the things. Got it? So how would we put those labels? These are the things. So to put the labels, we have some functions. One is called plt.xlabel. plt.xlabel. And to put a label on y-axis, we have plt.ylabel. Okay, suppose on X label, it is consisting of the marketing budget. And on the y-axis, we have the revenue, as we were talking about. Okay. Ravina, 25 is not the interval. This is a different thing. So why are you getting confused on that? I have already explained NumPy linspace. This you should have studied, right? NumPy linspace. If I keep explaining that, how can I talk about this? Got it? This is the values. This is saying that two arrays are getting created, X and Y. This array has 25 values. And this array has 25 values. Why this is causing confusion? X and Y, 25 values in the array. What is this? This I said 5 times. I've said that it is decided according to the minimum and maximum of that data. What is minimum in that data? 5. And what is maximum? 100. So it is deciding the range to represent those values, 5 to 100 here. And it is deciding the range automatically. You don't have to tell that difference will be 200, 200, 200. You don't have to say. It will be decided according to what is the minimum, what is the maximum in that column. Okay, everyone focus, because you're not focusing. Simple thing I told 5 times and still you're confused about that. Okay, next. Now, I'll show you those values. The values which have been plotted, I will show you those values. Basically what it has done, there are multiple dots created. And my line is connecting those dots. So that is why you're not able to see those dots. But actually there will be 25 dots created in this. What are these dots? These dots are nothing but the representation of this. The 5 and 10 that is being plotted, and that is a dot. 8.95 and 51.25, there is another dot. So there is a dot which is being connected to give us the line plot. It has connected that. That is why you're not able to see that, but I'll show you just in a few minutes. Now, so Partha, this plt.plot, plot is a function which creates a line plot always. Okay, so it is not deciding. This plot function is for plot. If you want to make a bar chart, you will write bar. That is what we are going to see one by one. It is not deciding. It is just created for that purpose. Now we have created this. I have given a X label. I have given a Y label. Then I have given a let's give it a title. So title I will give that this is talking about marketing budget versus revenue. Marketing budget versus revenue. I can just write this. Now see, we have got the information, which is my marketing budget and the revenue, and the title of the plot also I have given. So this title of the plot is telling you what? That this plot is representing the relationship between marketing budget spent by the company and the revenue. So that title is going to explain what this plot is trying to do. These are few basic things which you need to put. Now my plot looks a bit complete. I have the revenue here, I have the marketing budget, I have all of these things mentioned here. I can now understand this in bit more detail. Now let's do some modifications. As you can see, now we have by default a blue color. There's a line of blue color. Now, how is it decided that blue color will be there? That's a default color. Line has to have a color. It might have taken a black or a red or a blue. So by default, it is mentioned that whenever a line is created with this plt.plot function, it will have blue color as default. Next, what we can do, you can see there is a plt.plot function, x comma y is there. Put a comma there. Put a comma and now put a quotes. Put a comma and then quotes. Inside the quotes, put R. And see now what is going to happen. Now R is going to represent the red color and it will change the color of the line. Similarly, if you want it to be in green color, just mention G for green color. You can also mention the color like green. You have Y for yellow. You have K for black color. These are the colors that you can try. Apart from colors, do we have something else? There's something called as a marker. What is a marker now? Let's see. So if I say K of O, K and O. K is the color and O is the marker. Now look at it. What is going to happen with O? Look at this. The line which was there, which was a one smooth line in blue color, that has been broken down into these dots. And how many dots will be there? There will be total 25 dots. Total 25 dots. Right? So which means that these are the first value, first pair, third pair, fourth pair. These are the values. Next, after that, what is, I have used O, and according to O, the circles I'm seeing. When I put the star, star, now you can see the style of the plot has changed according to this, the star that I've given. See? Star. So K and star means black color stars. R and star means red color stars. Got it? Easy to understand. No technical definitions you have to see. Basic. R star means red color stars. And if you say R of plus, so red plus 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 plus. Okay, yes. O means O is the marker. Got it? O is the marker. That is the thing. I think for size, size may be 10. S is there not? No size. I think size is not there in plt.plot, or I will have to check it. Okay, I have something, maybe marker size. Do we have this? Let me put it. Yes, there's one of the parameter which is called MS. MS means marker size. So with the marker size, you can increase or decrease the values of it. So if I take 5, it will become little smaller. If I take it 1, it will become even smaller. Marker size. Okay, now. So these are the things. I have made the modifications. And now you can see this modification, why we have even done this modification. Because one, it looks better. but it has one more use case. Okay. The another use case of that is, suppose we have two lines instead of one, that these markers and this color will help us identify which line is for which function. So till now, I think everyone is clear about it. What we have done, plt.plot, x and y values, our markers and the marker size. Then I have given my x label. X label is the text which will go in the x-axis. Y label, the text on the y-axis, and the title of the plot. Basic thing. Now let's go and do some modifications. Now what modifications I will do is, I'm going to mention one more plt.plot function. Okay, plt.plot. So how can I, okay, share the code. One. I pasted that. Okay. Now we have one more plt.plot. I will take one more, and in this plt.plot, what I will do, I will take x and y into 2, suppose. X and y into 2. So let's remove the marker size for now, and let's have a look at yellow color stars. Now if you take a look at it, what we are trying to make, one is a plt.plot with x and y, means whatever values were there in the x and whatever values were there in y, you are trying to take one values, second values, and you are trying to plot that. So there was one plot you have created with this plt.plot, but I've written one more plt.plot. What is this another plt.plot is going to do? So here, if you take, I have taken y into 2, not taken y into 2. What does this mean? Just, I'm saying that create another array by the name y into 2. Okay, whatever values are there in y, just do the multiplication of it by 2. Whatever we mentioned, we put that into 2, and then make a relationship between this x and y into 2. Just multiplying the y values by 2, and that we are plotting it. Now, when you look at that, what are you seeing? You're seeing two lines, and these markers are helping you understand that which line is representing which of the plot. So the first plt.plot is represented by this one, and the second plt.plot function is represented by this yellow stars. So the marker is for this reason that we are able to understand which line is for which purpose. Next, these are the markers. Yes, of course, you can change the values also. If you say instead of x comma y, you mention y comma x here, then they will be changed. Okay, so in the first place is what it is asking you, the first value, it is asking that whatever you give me, that will be put on x-axis. Whatever you give me, whatever the data you give me, that will be put on x-axis. And plot function is saying that whatever second value you give, that will be put on y-axis. So earlier what we were doing, we were giving x array to be put on x-axis and y array to be given on y-axis. But if we change that, it is going to be changed. That is the thing.
Sir, is there any way to know the information about dots? Like the third dot denotes what information?
You can go to that plt.plot function. The explanation about it you will see in the function itself. So you just have to say plt.plot, make a bracket here and search for it. Once you search for it, you will go to the documentation page of any function which you're going to see. In the documentation page only, you will see those information. Okay. Here in this, you will see that it will be explained that the first x-axis value is needed and then the y-axis value. See, it is asking that you have to give the arguments. Arguments are some examples you can see. You have x comma y, you have x comma y with p and o. These are some information that will be given. Okay, and you can see the parameters. 1 minute, somewhere it must be written. You can see the first is it is asking for a parameter that x and y has to be given. What is x and y? Here, x and y is saying that either you take arrays or you take some scalar data. Scalar data means either you take one column of the data set or you take in 1D array to represent it. One will go into x and one will go into y. And you can see some examples also. First, it is taking x-axis and y. This is what it will tell you. Okay, now. And one more thing you can see, there is a line width parameter, which is going to help you change how much wide that line is, how much thin that line is. That is going to be done. Next. Okay, so you can see the line width. Now, take a look at it. Whichever function I'm going to talk about, you can search about that function by writing plt.plot with a bracket. See its documentation. You can see multiple examples. There it will be mentioned. So you don't have to remember anything, that the first value is this, second value is this. You can always search. Only thing you have to remember is the functions. There is a plot function, there is a bar function. Those are the only things. Now, can you see any problem in this plot that we have here? Can you see any problem? What I have done, I have created another plot in the same box. I have created another plot in the same box where I'm doing what? Y into 2. So with the first plot, we were representing the values like x and y. In the second plot, I'm representing the information of x and y into 2. These two arrays. Means I've taken the y array, multiplied it by 2 and created another array. Basically. Now, what is happening because of this? There is a problem that is happening because of this. Look at it. Anything that is changing, anything that should not have happened. Intervals. What is changing now? So as soon as I've mentioned y into 2, and I'm saying that this y into 2 has to be represented in this box only. In this box only, we have to do this. What is happening is here. What was the range in my data earlier? It was from 0 to 1000, right? When it was 0 to 1000, these red dots, they should have been here. The red line, which you see here in this way, this should have been here. But what is happening? You are changing the labels. You are changing the y-axis values by multiplying it with 2. Because of that, what is happening? Your line, the red line, which should have been actually here, it is now being flattened and it is going down, more flat. Okay. Now, what is the problem with this? Two lines are there. What is the problem with this being flat? So basically, the problem is that a line like this represents a strong positive relation. And a line like this, which is more flat, it represents a weak positive relation. Got it? Now, this red line is telling us when you look at this and when you interpret that, what will you say? That this line is saying us that there is a weak positive relationship between my x and y. But the yellow star is saying that there is a strong positive relationship. Is it actually having a weak relationship? No. It does not have a weak relationship because here just we have seen that the line was like this. The same data I've taken, but now because of changing the scale, it has become from here to something like a flat. Why that has happened? Because your scale of the y-axis has changed. See, you know that the x is going from 0 to 100, that is okay. But y goes from 0 to 1000. So if you look at, there is 1000 here and I create a line from here. This red line is supposed to be inside that. So red line is supposed to be below that 1000 because y is till 1000. But now y into 2 can go till 2000. That is why it is going till 2000 like this. There is a problem. Basically, I try to say that this scale should not have changed. If this scale is changing, my interpretation is changing about the lines. How can we solve this problem? What do you think? That both the lines should have shown me the correct interpretation. How can we solve this problem? Yes. Okay. Okay. So you're saying that if I do x into 2. Now, if you're doing x into 2, you're changing the data again. One time you have already changed the range of the data and you're saying that we will change the data again. So that is going to make it even more difficult. You're bringing difficulty into the interpretation. So why do that? Why not do a very simple thing that create another plot? Why not do a very simple thing that create another plot? And what we will do here, we will say that in this one, the values will be from 0 to 2000. And the yellow one, it will be here. I will make the yellow one in the next one. And the red one will be in my first one. And here the range will be from 0 to 1000. This way, I will be able to read the red one also. And I will be able to read the yellow one also. And I will be able to do proper interpretation of both of them. Because the values, the ranges are not going to change. The intervals are not going to change. Correct? That is going to solve our issue. So whenever you face something like that, that your labels, the ranges are changing, the values on x-axis and y-axis are changing, and your interpretation becomes difficult, you break it down into multiple plots and then you visualize the information. Got it? If you want to analyze them in single, you can analyze them. That both are the lines, both are going positive. That will be the analysis. But there will be one thing missing, that you will think this red line is giving you weak positive relationship. That you will be thinking, because that is what these lines represent. The more upward they are going, the more stronger the relationship they represent. Okay, you will be able to analyze like this also, but not completely. That limitation will always be there. So how to create that? For that, we are going to talk about the concept of subplots. Now, what is subplot? Let's take the same code. Only this much. Okay, I'm going to paste it for you if you want to run this. Now, I'll only take this much, the Y label, X label, title, that I'll add later, but just for this. So when I'm using this toPLT.plot function, there is a problem happening that both are in the same and my y-axis is changing. I want to solve this problem. To solve this problem, there is a concept of subplots. There's a concept of subplot. What we need to do here. So now, just separate them a little, the first PLT and the second PLT.plot. And above this PLT.plot function, mention PLT.subplot. Mention a PLT.subplot. Then for the second one, above the second PLT.plot function, also mention one PLT.subplot. Mention one PLT.subplot. And then the show part will be separate of that. See, this I've taken, above that I've written PLT.subplot. This I have taken my plot function and just above that subplot function. Now, when you do that, it requires some number to be written inside the bracket here. In this bracket and this bracket, you need to write some numbers. What is the first number? So the numbers in the first box, suppose I write 1, 2, 1. And here I'm going to write 1, 2, 2. I'll explain, but let's see what is happening with it. So are we able to do what we have thought about? And you can see in the first box, the ranges are from 0 to 1000. And in the second box, we have 0 to 2000. And now see, the red line is also going upward like this, and the yellow line is going upward like this, means both are representing a strong 10. I'm able to compare them also. I'm able to see them properly without changing their interpretation. Both the things I'm able to perform. There's only one short issue, small issue, that these values are overlapping on each other, right? That I have to solve. Okay, that I'll have to solve. Now, what are these numbers? What are these numbers? That is what we need to see. Let's have a look at it. Now, if you observe, the first two numbers are same. And the first two numbers will always be same. Okay, now what do they represent? 1, 2 means in one line, you have to create two plots. Okay, 1, 2 means in one line, you have to create two plots. If I do 2, 1, what does 2, 1 means? 2, 1 means in two lines, 1, 1 subplot. One line, two line, in two lines, 1, 1 subplot, basically top and bottom. 1, 2 means in the same line 2, and in 2, 1 means like this. Other. Let's suppose I have to make, yes, horizontal and vertical. Suppose I mention now this. For 4. If I have to make 4 subplots, then what does it mean? Yes, so 1, 3 means in one line, 1, 2, 3. And 3, 1 means 1, 2, and 3. This is what 3, 1. Now, if I have to make 4, how will I make 4 subplots? One is 1, 4. Second is 4, 1. So here there will be 4, and here also will be 4. Do we have one more option for 4? We have 2, 2 also. So basically, to make any number of plot, the numbers you're writing, if you multiply these numbers, that is the maximum number of plot you can create with these two numbers is 4. If you multiply them also, 4, basically with this two numbers, you can create 4 maximum subplot. Similarly, for 4, I have 2, 2 also. What does 2, 2 means? 2, 2 means in two lines, 2 plots. Okay, 1 and 2. 2 lines, 2 plots. That is what 2, 2 means. So the first two numbers are always going to be same. What is the third number telling you? Third number telling you that out of 2, this is my first subplot. And out of 2, this is my second subplot. That is what the third number represents, the number of the subplot. And that's subplot. Okay, yes. Yes, for 6, you have 1, 6, 6, 1. Yeah, 2, 3, 3, 2. Yes, exactly. Exactly. Got it? Now, so this is the thing. Third number represents which is that subplot. That this is my first subplot out of 2, and this is my second subplot out of 2. This is the case. If I make it 1, 2 is there, instead of 1, 2, if I make it 2, 1, remember that the first two values of both the subplot should be same. 2, 1, it will be like this. This is the concept of subplots. Very, very simple, very easy concept. 2, 1 means in two different lines, 1, 1 subplot. But now take a look at this thing. Let me keep it 1, 2 for now. have a look at this. When I'm creating my subplot, okay, I'm able to do that. But the problem that is happening, can you see that it is a very short, very small things are there. Very small boxes are there. Okay, that's a problem. And even second thing, you can see that the values of the y-axis of the second one is overlapping with my first box. There should be some space between both of them so I can see them properly. Why this is happening and how do we solve that? So to understand that, let's go to one of the plots. Let's go to this plot. See, or let's go to this plot. See here, this plot that I've created, it is occupying some area. If I create a boundary around that, if I create a simple boundary around that, so you can see that it is occupying this much area. Some invisible form of container is there, and it is not being made. The figure is not going bigger than that container. If I just take this same container and if I try to look at the second plot, is it the same? Yes. If I go to the third one also, is this also same? Yes. Which means that there is a predefined size of a container, and in that container only you have to make one plot, two plot, three plot. All the number of plots will be created inside this only this size of container. That's a problem. Now, how can we make this? How can we solve this problem? Okay, how can we solve this problem? If I make this container big, will it solve the problem? If I make the container bigger, these two plots which are there, they will expand and I'll be able to see them. Correct. So what basically I have to do, I have a container which is of this size. And if I make the container bigger, more wider, more lengthy, then that will solve the problem. Padding kind of thing. Exactly. How do we increase the size of the container? To increase the size of the container, there is one thing which is called figure. So these containers, these boxes which I was talking about, they are called figures. Okay, they are called figures. I will say plt dot figure, right? Plt dot figure. Before any plots you are making, before that only you have to write this. Okay, to write this. Then you have to mention it fig size. Figure fig size. Error. Paste the code so I can see. Bhanu, paste the code so I can see. Now figure size. I'm writing plt.figure. Figure means that container. And you're saying that what will be the size of that container? The size of the container is going to be, suppose I mentioned 7,6 as an example. Now you see what has happened to it. What has happened to it? You can see this container has become little lengthy and little bit big as compared to what it was before. Got it? Whatever it was before, now it is better. Let's try to another number. Let's have 10,5. Yes, I'll explain. Now see, is this even better? The 10,5 that I've written into this figure size, this is even better. What is 10? What is 5? So 10 means 10 is the width of this and 5 is the height of this. Some units, the more the value you take, the bigger and lengthy they will become. So 10 units on this and 5 units, the height of that will be the size of the container. So the container which was smaller in size earlier, now we have increased the size of that container. Now the plot becomes better to read. Okay. So this will, see Sujata, automatically it will increase the gap between them. Automatically. So Ravina, there is no thing like the maximum size of the container. You should not be making too big that you're not able to see that. Okay. No, there is no fixed size, but you know that if you try 25 and 30, it will become too big. That is the thing. Okay. Yes. So if you want to increase the gap between the container, there is no such thing to increase the gap. When you make the figure size bigger, it will automatically increase the gap between them. But there is one more option which you can try. What you can do, you can say that put them into different containers. So suppose I say that take a container of 5,5 and take another container of 5,5. In first container, my first plot will be there. In another container, another plot will be there. So now you will see them. They will now be in different places like that. You're changing the containers. That is the only thing you can do. Apart from that, you cannot increase the width of that. The gap between that cannot change it. Okay. Now, yes, one plot in one container. Exactly. Now, how can we give the labels to that? Now you can see there is a plt.plot. Means two plots are there. So they both will have their labels, right? So I'll say plt.x label for this, plt.y label for this. And for this also, there will be a plt.x label. X label. And for this also, there will be a plt.y label. These are the things. So whichever plots you have to just put that into this. Okay, you have to put that into this. Now, what you want to do, you have to give the labels basically. On x-axis x, and this is my y, and this is x. Suppose, and this is my y into 2. And you can see now you will have the labels x, x, y, y. These are the things. Okay. This is the concept of subplots. Now, one thing is remaining. One thing which is called the legends. What is a legend now? You must have seen something about that. But let's try to understand those legends more properly. Now, suppose I take this one, this example I'll take. Legends. What are these? Now, if you look at this, I have two plt.plot functions. Okay. And legends you use when you have 2 or 3 plots in the same box, then only you use the legends concept. Now, what do we mean by the legends? Legends is this. For creating the legends, first, what you need to do, you need to go into plt.plot function. You need to put a label. The label that this plot is between x versus y. And you have to give a label here that this is a plot between x versus y into 2. Labels. And after the labels, you need to put plt.legend. You have to use the plt.legend only when you have given the labels, then put the legend. Now see what is the legend. Legend is this particular information in this box. It will represent that the red one is x versus y, and the yellow dot, yellow star is for x versus y into 2. It will help you identify that which line is representing what relationship. Legends you can add. Okay, now there are some modifications you can do to these legends. Like One thing is this here, location. So location of this legend, as you can see, is on the top left corner of it. If I want to bring the legend from here to here, how would I mention that? So by default, what it will do, by default, the legend will be either here or here. So as you can see, there was no space here at this point. That is why it was created here. By default, these are the two locations. But if you want to change the location of that, you can say location is equal to lower right. And now what will happen? Your legend will go into the lower right corner of that. You can change the location. Second, you can see there is a border around that legend. Border, some small black color border is there. You can make it more transparent. So to make it transparent, there is a concept called as frame alpha. If you say frame alpha is equal to 0, you see that boundary which is there, the border which was there, border will be gone. If you make it suppose 0.5, 0.5 means the border will be there, but more faded, more transparent. 0.2, border will be more transparent. So smaller the number, the more transparent, and maximum you go till 1. 1 is the most visible, you can see. And if you go till 0, it is going to be completely transparent. Got it? These are the things. You can also plate this. Maybe you can try this. What is this? There is a face color. What you can do with face colors? Let's suppose I've written face color to be in cyan color. It is not taking cyan. Let's me try with red, suppose. Just face color basically changes the color of this. Why is it not taking it? Pink. 1 minute. Yes, maybe I have to increase the alpha. Yes, now. Alpha. This is the thing. So now you can see the face color. The color of this box is now in this side. Like this. How to display the values? Values you don't display. No. There's no option to display the values, because even if you display the values here, it is not readable. It is just going to make hodgepodge and you won't be able to see the line. We never put the values here. That is not the thing. That is what I said. When you're making the plots, it is not that you're going to see the value of this, you're going to see the value of this, you're going to see the value of this. If you try to do that, then it is not going to serve the purpose. We made the visualization so that we don't have to read those points, those particular values. We have created the visualization for that purpose only. That is the thing. Okay, you just have to see where they are going.
Hello, sir.
Yes, yes.
So my question was actually at times what we do is in the displaying the data, we have an option wherein below the legends, as you could see, the bottom label, what you have over there, other than the below the marketing budget, we can fix a table wherein we can display x-axis, y-axis against the actual values. So we have this option in the PPTs whenever we do the display of the graphs. So that's I mean, do you have any provision over here to fix those values?
No, I have not seen that at all. I've not seen this. Any visualization, I've not seen that. Might be I have to search for that, but I've never seen. A lot of things I have worked on, I've not seen that. Okay. Maybe this might be possible in the tools like Tableau and Power BI, but at least in Python, I've not seen that option. Okay. So these were some basic fundamental things about the plotting, the concept of legends, the concept of plot, the concept of subplot, figure, the titles, the labels, all of these things we have understood properly, and we now have a good amount of idea about that. Now we are going to talk about the type of plots which we need to know. But before that, we'll take a small break and then we will talk about the types of plots. Okay. So which plot has to be created on which type of data, that we will see. Okay. No, is it? Yes, we are going to work on real data also. Yes. This I was taking this small simple data because it is more easy for you to see with this smaller data. If I take directly a bigger data, that would be difficult to explain. That is why I have taken this. Okay. So Harish, we can go for a break, and then after the break, we'll see.
Yeah, sure. So guys, it's time for a short break. The session will be continued after 10 minutes. Yeah, hello everyone. I hope everyone is back from break. So let's continue the session.
Okay. So just now we saw the example of basic plotting. And now what we have understood is the plot, when you make it, how do you decorate it and how do you put more information into that plot? We have seen that. Now we are going to talk about the types of plots. One type of plot that we created just now was a line plot. We'll do this with a data set also. But for now, I just did it with a dummy data, a normal NumPy array. We'll do with the data also. But before that, let's have a look at some other type of plots. Then we will get to line plot once again. The first one which I'm going to create is going to be our scatter plot. Scatter plot. Now, what is the scatter plot and for what purpose it is going to be created? We'll have a look at it. Okay. Check some spelling mistakes. I will give you the code again. Take this code, paste it, and compare it with this. Sorry with this. Okay. Now, the scatter plot. For the scatter plot, I'm going to read data. We have talked about the dummy data arrays for now. Let's bring in the actual data sets and then see how do we plot those information from that. So I'll take a data is equal to pd.read CSV. And there is a CSV file which is marketing data.csv. Okay. Now, if you look at the data, it looks like this. Paste the second one. Okay, paste this one. I'll give this one. I think this one is the correct. It should not be giving error now. Try it once again with this one. Shouldn't be giving error. Okay, now see. I have a CSV file. In the CSV file, there are two basic columns are there. A small data to help us understand the things about the scatter plot. Two columns are there. One is a marketing budget column and the actual sales column. What we want to do, see, the first thing is when do we use a scatter plot? Okay, the very first thing that we need to know is when do we use a scatter plot, right? So use of a scatter plot is, you have to do is when Just a minute. Yes. So scatter plot is used for representing two columns of the data, both continuous. Okay. So scatter plot, whenever you use, it is created to represent two columns of the data, where both the columns will be continuous data type. As you can see, these are continuous data type, these are continuous data type. Whenever you have continuous data, numerical continuous data, that is what you use to represent with a scatter plot. And scatter plot is best used for that purpose. Now, but if you look at the data, there is a small problem. Basically, from row number 17 to 22, there are null values. So by mistake, it has taken some values. Only till row number 16, my data is present, but by mistake, it has taken some extra rows. So what I need to do for that, I need to just do the basic cleaning of it and do with this data.drop NA. This is equal to true. So what will drop NA do? Okay, what will drop NA do? Drop NA is a function which is going to delete all the rows which has even one null value. If in a row there are, suppose 5 null values are there. If in a row there are 50 values, but out of 55 are missing. So it is going to drop that complete row even if it is having one single missing value. So I am using it here because I can see that these rows are completely empty. So I am just going to drop it with this data.drop NA. In place is equal to true means delete it from the original data, not from a temporary one. Now, if you look at that, those rows are gone, and now we have a clean data. This proves a point. This tells us a thing that whenever we are making a plot, we have to clean the data before it. Whatever missing values are there, either you fill that missing value, remove that missing value. You have to do that. Otherwise, your plot will not be created. Or it will give you rubbish results, unnecessary results. Now I have a data. So what we are going to do with the scatter plot? In the scatter plot, we are going to mention these things. First, the function which is used for creating a scatter is plt.scatter. Plt.plot was for line plot. We have plt.scatter to create a scatter plot. In scatter plot also, I need two columns. One column will go in x-axis, one will go in y-axis. So one will be x, one will be y. But what is x and y here? I have to mention that. X is equal to what I will take in x? This column. Okay. I will take one column in my x. I'll say data, name of the data frame. Select that particular column. And in my y, I'll take that data and select the another column, which is my actual sales in crores. Okay, and I put them. Now, what I've done, x and y I've created with the data. One column value, whatever is there, that I put in x, another column value, whatever it is, I put that in y. Then I say plt.scatter, and then to display it, plt.show. Let's create that. Now, if you see, I have created a scatter plot. What are these scatter plots telling us? So this basically represents the strength of the relationship and direction of the relationship. What does it represent? Strength and direction. How direction, how strength? Let's see. So I think you must have seen this in the correlation concept in statistics. So see here, whenever you see a scatter plot, you don't have to see what is this point, what is this point, what is this point. No. Pinpoint answers you don't have to see. What you have to see is this. You have to make a line, and that line should be passing through the data. That is what we need to do. That is the line I have to pass. The line passing through the data point basically represents that these are going towards the upward direction. That is what they represent. Okay, so one is direction. So all the points you look at, and in whichever direction they are going, that tells us the direction of relationship. They are going upwards, which means that positive. Now, what about the strength? Is it having a strong relationship? Is it having a weak relationship? So do we get that from there also? See, the strength of the relationship is given by how far away the points are from each other. Let's see. So see these points, how far away from each other they are. That represents the strength. The closer they are, all the points are very closer, then that would mean that it is a very strong relationship. And if they are very far away, it will represent a very weak relationship. But as you can see, these points are not very far away, not very close also. So they might represent something in between. How can we check that? To check that, I will say data dot correlation. See how much is the correlation between them? 0.95, which means that they have good amount of strength between them. That is what this correlation value represents, that between the marketing budget and the actual sales, 95% is the strength, 0.9, which is quite good. I think you have studied about this correlation also, right? Now, far away from each other, mainly. Far away from each other, the data points. How far away from each other? Okay, so this is a scatter plot. Now, what modifications we can do in this scatter plot? One is the size. If I say S is equal to 100, you see the dots become bigger. If I mention color, if I say color is equal to what? Suppose cyan, it will become like this. If I suppose mention yellow, it will become like this. Not very properly, too much bright. So other thing I can take is, let's say, magenta. That is the thing. Complete color list is given in, I'll show you. You can search on the Google also, what are the complete color list. But you can see color is equal to magenta, you have given. And also there is a marker. If you say marker is equal to, suppose the star. Suppose marker is equal to star. So instead of those dots, it is now going to make the stars of the size 100 of the color magenta. These are the changes you can make. Okay, next. One more thing you can do is you can create a grid. Those X label, Y label, title, you can add that. Okay, X label, Y label, title, those three things you can add. But there is one new thing which is called a grid. What is this grid now? So basically the grid is telling us about this. It will make a background with the grid. Why do we use the grid? Grid is going to help us understand this point. Like this point is on 200 and this is here. That is the grid value. Okay, so grid is just basically helping us to map the points according to that. But we can play with the grids. What I can do with the grids, I can change the style of it. So suppose I say that these grids are there. I say that make the line style to be dashed. See, the straight lines which were there, the smooth, solid line which was there, now it will be converted into dashed. Okay. Next. Next, we have the line width. Suppose I say line width is equal to 2. So see the grids which were there, they have become more thick. Thicker. Got it? And then I think there is a color also. If you say C is equal to R, then the grid will become red color. Not proper, should not do that, but this color also you can do. Okay. Data correlation. See, correlation is a concept which always show you the strength. Correlation is a concept. I think it should have been taught to you in the statistic concept. There are two things. One is a covariance, and then one is a correlation. Got it? If you don't remember that, no issues. Covariance is something which shows you the direction of relationship. S is equal to 100 is the size of these points. If you make it bigger to 200, you will see the stars become even bigger. Okay, now, so covariance is a concept which shows you the direction of relationship. But the correlation shows that the direction and strength. Direction and strength. How does it show direction and strength? Yes, any range above 0.80 considered to be strong. Any range above 0.80 is considered to be strong. Below that, it is considered to be average and weak. That is the correlation path. Yes, here only S, no MS, only S. 0.5 is a weak relationship. If you get weak. Got it? These are the values. So this was about the scatter plot. Now let's move forward to the next one. Let's talk about the pie chart. Okay, pie chart. Second one, pie chart. Yes. So yeah, you can, there's no defined point, but you can make a relationship like that. In the correlation, you can say that the values from 0 to 0.5, they are weak, positive. Why positive? Because whenever the correlation numbers are positive, it means that there is a positive relationship. But if the values are 0 to 0.5, it is considered to be weak. And you can say from 0.5 to 0.8, 0.5 to 0.8, you can say average. And 0.8 and above, these are strong. The closer it is to 1.0, the stronger the relationship. Got it? The closer they are to 1, the strong. Guru, yes, this was the one, data.drop in it already. Now, pie chart. Which shortcut key? Shortcut key is escape and M. Escape, ESC plus M. This is to convert code cell into markdown. Escape and M. Next, let's talk about this pie chart. So for the pie chart, I'm going to read another data. The merged is equal to pd.read.csv. merge data.csv. There's a merge data.csv that I've shared with you. And if you look at that merge dot head, try to understand it first. Okay. Now, this is the merge data that we created by joining it in the pandas concept. If you remember, we combined multiple things. Now, when you look at pie chart, what is the type of information can you represent with a pie chart? So Jata, in that case, if NA is not there, it will have to be converted to NA, then it will have to be removed. Got it? Yes. So which are the columns that you can represent with a pie chart? Remember that whenever you're talking about pie chart and bar chart, they can represent the same information. Pie chart and bar chart. Which columns you will represent? Always one categorical column. Remember this, always one categorical column, never the numerical values like sales, profit, product based margin. Don't represent the values like this in a pie chart or a bar chart. In a bar chart, we represent the columns like this: customer segment, the product category, the region, the product subcategory. These are the things we represent with pie chart and bar chart. Let's have a look at it. Yeah. Yes, that has to be done in the pre-processing phase. So basically, if there is another value which is not NAN, there's an np.nan. You will get to see that in the upcoming sessions. You can convert any value using this np.nan to become NAN. And once you convert it to NAN, then you can drop the values. That is the identification of the null values. It will be shown to you in machine learning, because machine learning, before applying that, the cleaning has to be done. So talking about the pie chart, how can we create a pie chart? First, let's look at the merged. In the merged, there is a product category column. Okay, product category column. In the product category columns, if I suppose apply the value counts, what is it representing? It is representing that office supplies is written how many times, and technology is written how many times, furniture is written how many times. So we understood this data in the Panda session. This data is basically saying that a company is there which is selling office supply product, technology product, and furniture products. Now, how many office supply product, how many technology products, and how many furniture? These are the numbers. So total 8399 products are there, out of which these many products are related to some office use. These many products are some technology products, and these many some furniture products. These are the numbers. Now I can compare it here also. That this is the biggest, this is the smallest. I can compare. But it would be much better if I am able to compare that in more graphical manner. So how do we represent this information? With a bar chart and pie chart, both we can represent. Let's create the pie chart first. So for making a pie chart, I have to say plt.py. plt.py. Then I will mention this. This particular thing I have to mention. And then just say plt.show. Then we will make changes to it. Say plt.show. Now, as you look at it, according to the data that has been given, according to the numbers that we have given here, see, 1 is very big number. So for that, there is a slice for that. Then there is a technology, for there is a slice, and then there is a furniture, there is a slice. So the biggest part is for the office supplies because it has the biggest number. So now I'm able to see that, but I should have a label, right? To see that this one is for this one and this one is for this one. Label should be there. How do we put the label? So one, I can put the labels manually, or second, I can put the labels in a little smarter way. So what I will do here now is I will say this dot.
Excuse me, sir.
Yes, yes.
Yes, sir. Sorry to interrupt. Actually, sir, due to bad network connection, I have missed line number 65, sir. Please.
Okay. So 65. This is a value count. I said that you go to a categorical column and check the value count. What does this show? The value count. The value count shows that how many times a particular value is being repeated in that categorical column. See, office supply is repeated, right? How many times? That is the number written. Then technology is there. How many times that is repeated? That is the number written here. And furniture, how many times that is repeated, that is a number written here.
Okay, that pandas concept. Okay.
Yes, pandas concept. Yes. So this is the thing which I want to represent graphically. Now you see, I have applied that, I have taken this value counts and I made the pie chart. But I want to have the labels also, right? The blue one is for which one? For labels, I will put a comma, I'll put a labels is equal to what? One thing, I can copy this list and paste the list here. And then I can run. Yes, I'll share whole file completely, of course. That is why I said you focus on learning the things, understanding the first things for now. Later you'll have the file, you can practice. So if you look at it, the labels are, instead of writing it manually, it is much better way that I see the unique values and then I copy that list. And even better than that, what will happen is this. I take the code. This particular code, which is giving me that this list, I will put that code itself. That would become even better. Okay, and let me run it. Same thing. So now I don't even have to copy that. I don't even have to copy that. Yes or no? In the pie chart, always it will be outside. The numbers you have to mention inside are different things. Got it? Yes. So the pie chart, what we have mentioned here, what will be the amount of area, what will be the amount of that particular part, how bigger that part will be, is defined according to the numbers that you have taken in the value count. 4610 for office supply. So this is the biggest slice it has taken. And then to give the labels, I've used the unique values in that column. That becomes my labels. The way which it has been mentioned here, the same way it will show here also. Now, you want to also see the percentage, right? That how much percentage is this office supply, how much percentage is technology, how much is the furniture. So for that purpose, there is a concept which says that auto PCT. So we say auto PCT is equal to %.2f. What is %.2f? It is saying that show the percentage of that slice, and after the decimal, there should be two values only after the decimal, not more than 2. Now, if you run that, you can observe something even better. That office supplies are, there are 3 types of products this company is selling. Out of these 3 types of products which this company is selling, which is most? So company is selling 54.9% of the products this company has sold was related to some office related products. 24.6% of the products this company has sold was something related to technology, and 20.5% products this company has sold was related to furniture. If you want to see the numbers are visible at the value counts. You can see from there. Okay, numbers are visible here. Percentages is what we see. Percentage is what we see. You will be able to do much more than this when you go to the concepts like Tableau and Power BI. So here the thing is that you can only make a 2D pie chart. If you want to make a 3D pie chart and all of that, that will be better created in those library, those packages and tools which are Tableau and Power BI. Color. Okay, you want to change the color. So for color, you can do this. Say color is equal to, suppose I want to create a red color and a orange color, and then I want to have a magenta color. What is the problem? Colors. Yes. See, Sachin, there are 2 things. Yes, this value 0.2f means after the decimal 2. See, this is telling you percentage. 20.53 is the percentage. So in the percentage, you have to show the value till 2 decimal places. That is what you're mentioning with 0.2f, means after decimal, two values. If I mention 0.3, you will see after decimal, there will be 3 values. Okay, 3 values. That is the thing. Now, F is formatting concept, that format the numbers in such a way that after the decimal, show the three values. Tools are rather than matplotlib. See. Yes, Mamta, exactly. No need to remember so many things. Even if you try to sit down and remember this, you would forget this. So don't try to remember these things. Got it? Now, whenever you require these kind of things, you can easily search on the Google that how can I make a pie chart? All of this information, many examples will be shown. As of now, I'm just showing you so that you get some idea. And you basically, when you're reading the code, you must be able to understand what that code means. That is what we are doing. But anytime, don't get worried about how will I remember so many things. That you don't have to worry about. Once you start making the projects, most of the things will become even clear. Yes, about the industry. See, there are 2 things. Where are we going to use these visualizations? Understand this one thing. There's a concept of end-to-end data science project. What is end-to-end data science project? That you read the data, then manipulate it, visualize, okay, visualize and analyze, and then do predictive analysis. Predictive analysis. Predictive analysis means basically machine learning, ML part. So Python, why are you even studying about a package of Python when you can do these things much better in other tools like Tableau and Power BI? Why are we even studying that? So if you have to create a complete data science project with Python, that everything is there in one file. I don't need to look at some information in SQL, some information in Excel file, some information in Tableau. That would become too difficult, right? So what Python does, Python takes the concept of Excel also, SQL also, Power BI also, Tableau also, and it combines everything into one place so that you can make a project from start to the end in one file. And this is much better. If you have everything, every detail in one file, this is much more readable as compared to going and referring to different files. Now, it is not that you will not be using SQL, you will not be using Excel, you will not be using Tableau, but those will be to magnify a point. Whatever you are not able to do properly in this, you can do that more properly in that. But at least some idea you will be getting in Python, some sort of visualization, some sort of manipulation you will be able to do here. Got it? So it is mainly to give us an access to create an end-to-end data science project. All the things are there too. With us. Yes, final will be in our notebook file, which is our .ip file, notebook file. Yes, that is what the purpose of all of these things are. Python is being developed as one-stop solution. Okay, it is being developed as a one-stop solution to do everything which the SQL can do, which the Excel can do, which the Tableau can do. But of course, those are very powerful tools. Everything Python cannot do, but most of the things Python will be able to perform. And it is being made better and better over the time. Okay, yes. This is the code for that. So I hope this pie chart is clear. Now, very similar to that, we can create a bar chart also. As I said, that bar chart is going to represent almost the similar thing. So how can we make a bar chart? Let's have a look at that. So we'll say plt.bar. Okay, whatever we represent in a circle here, we represent with the buildings. No, 3D plotting is not possible in Python. For 3D plotting, you'll have to use the Tableau and Power BI. Those are much better suited for that. Okay, 3D plotting not possible. Now we have plt.bar. What is this plt.bar going to do? Going to make a bar chart for us. What are the things we need to mention? So we need to mention this. Let me write it down. So the first point that I will have is this. Okay. Now I'll say plt.show. If I do that, it will not work. It is saying that I need one thing which is called a height. Let's put the height. What is height? Let's understand that also. In the height, I will put this. Okay, in the height, I will put this. And then let's understand what is basically telling us. See, the same information which was represented by the pie chart, that the bigger slice was there for the office supply, the same information we are able to see with the bar chart, with the buildings. Now you can see that office supply is the most here, technology, then furniture. Much readable in the building form, as you can see. Exactly. Now, when to use a pie chart, when to use a bar chart? See, if many categories are there, I have only 3 categories. So if I have like 15 categories, making a pie chart will not make sense if I have 15, 20 categories. In that case, you will have to prefer using a bar chart. But since there are 3, 4 categories, for that purpose, you can use a pie chart. Yes, Tableau has a more scope. Tableau is used in, you can say 80% of the companies use Tableau, because Tableau can handle a very big amount of data as compared to Power BI. But if you learn one of that, other one is easy to learn. Okay. Mainly Power BI is much easy, you can say. Power BI is, Tableau is much easy. Power BI is a little difficult. Yeah, Power BI you can learn in, I think, 3 to 4 days. Whatever is enough for you to know in data science, you can learn that much Tableau in 3 to 4 days only. But Power BI, I think it will take 20 to 25 days at least to get an idea about that. So now, when to use a pie chart, when to use a bar chart? When you have many categories to represent, then bar chart will be preferred. If you have small number of categories, like here we have only 3 categories: office supply, technology, and furniture. In this case, I can use both of them, because I cannot make that circle bigger. Circle has a limited area. So in that area, it has to show multiple of that, but I can make multiple buildings here to see that. Now in the bar chart, I can play with some of the things, like I can say the width. I can say width is equal to, suppose I mentioned 0.5. So what will happen? The width is going to change according to the number I've mentioned here, and it will become thinner. Width. Okay. Now, there's a thing which is called X-ticks. Ticks, basically, in bar chart. So what I will mention, I will say plt.xticks. Next. What is this X-ticks? And why is it used for? See, these names. These names. If you have 25 buildings like that, and all of these buildings have names, they will come very closer to each other. And when they come closer to each other, if they have a little lengthy name, they will start to overlap on each other, and you will not be able to read these names. Okay, you will see that problem in the upcoming sessions. A lot of time, what happens when you make bar chart, there will be many categories and the names start to overlap on each other. For that purpose, what we need to do, we need to take this rotation. Rotation is equal to, suppose, 90 degrees. So what will happen? These names are going to be rotated by 90 degrees, so that when the buildings come closer, the names don't overlap, you will be able to see that properly. This is the concept of X-Ticks. Now, why we don't have to rotate? We can rotate the Y also, but X is something which we need to rotate. Inclined also, yes. If you mention 45 degree, then it will be with 45 degree. Can have them. But mainly we use 90 degree mainly because that is much easier to read. Can have it inclined. That's a degree. 60 degree, 30 degree, 45 degree with what you want to rotate that, you can rotate it. Bar chart. Yeah, colors also are there. Colors, for that you need to mention colors is equal to. Again, the same thing. I can give a red color. Okay, maybe I take magenta color and suppose purple color and red color. Okay. This. Okay. No, display of the values is not allowed, is not given here. You can display the values. There is a very indirect method for that. A lot of functions and everything you have to do, modify the values here. But there is no direct method given in bar chart to give the values. Okay. On top of this bar, if you're saying I should be able to put the numbers, how big is that? There's no option given for that directly. Okay. And if you want to do that indirectly, you can search for that. There is a lot of indirect things you will have to do, functions you have to create, modify the values, but no direct. Why it is not given? Because our purpose in the bar chart is not to see what exact value is this. I can see that with this value counts. Correct. I can see that with the value counts. But the purpose of the bar chart is, as I again say, is to look at it from the broad perspective. Office supply is the most, furniture is the least. That is the basic idea we need to get. We don't need to get into the details of those numbers. That is what I was saying multiple times. That in the visualization, we don't have to get into that. Exponential curve with a line plot. Not here, but only with a line plot. Exponential. Okay. So now you can do here also, Guru. If you go here and you want to see exponential, you can say y square. Take the y value and square it. Then you can see exponential. Got it? That is the way. So in only the line chart it can be done, but for now, in the bar chart and all of that. No. Yes, the trend itself, that trend is represented by the line plot only. So in the line plot only we do that.
Hello, sir.
Yes, yes.
Oh, so I remember something like, we have this thread line or something where we connect individual bars and, we draw that sequencing in the Excel or something. Say, for example, the first one, the office supplies and the technology. The peak value can be connected with a thread line or trend line, what we have. So can we have those trend lines over here? In the Excel, we have that option.
No, I have not seen that. In the function also, if you look at that, there's no option to that, to give that. There's no option given here. Only the trend line is only created with the plt.plot function. Only there we have the option to create those trend lines like that. But in this case, there's not there's no option given to touch the points of this. Okay. Now, the bar chart is completed. After the bar chart, now we have completed basically the concept of this one histogram is remaining. Suppose histogram. So we were talking about pie chart and bar chart, the histogram, both. Now, what is the concept of histogram? What does histogram do? Histogram is going to show, yes. Histogram is a tool which is going to show the distribution of the data. And also, second thing it will show is that in what range the values are concentrated. That is what the histogram is going to show. Now, for that purpose, I'm going to use the merge data itself. Now, what do you take in a histogram to represent? In a histogram, you take one numerical column. In bar chart, we take one categorical column. In histogram, we take one numerical column. In scatter plot, we take two numerical columns. These are the things we have seen. Histogram. So I will take, let's suppose, the sales column I can take, profit column I can take, order quantity I can take. These are the numerical columns I can take. So let me have it. plt.hist. 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 So what I will mention here, I'll mention my merged and the sales column, and then I'll say plt.show. See, now what is this representing? It is just representing the values in a certain range of data. Okay, so to understand this histogram, we will take a look at the merge.describe function of that. In the sales column, what is the minimum value? The minimum value is 2.24. What is the maximum value? This much. How much data point are there in the sales column? These many data points are there. 8399 values are there. The minimum is 2.24 and maximum is this 89,000, which means that, which basically says that there are 8399 values between 2.24 to 89,061. 8399 values between that. But of course, in all the cases, the data is not going to be present uniformly in those ranges. Uniform present, the concentration of data will not be present. In some range, a lot of data will be present. In another range, a very less amount of data will be present. So now what is this histogram telling us? Histogram is basically showing us where most of my data is present. Which is, if you look at the numbers here, on the y-axis, we have the sales value, x-axis. Here we have the frequency. So I think you must have seen the histogram before also. So it is showing that between this value to this value, let's suppose this is 7,500 something. I said that histogram is to be used with a numerical column. Any numerical column that you have, you can use a histogram with that. It will tell you something which you are trying to look. What it will tell you? Distribution, whether it is a normal distribution, is it a skewed distribution, and in what range the values are present, you can use that. Okay, now, what is it telling you? Mainly it is used for continuous in the data set. It is mainly used for continuous values, but sometimes you will see that it is being used in integer. But most of the time, we use that for continuous. Most of the time. Have a look at it. There's a building at the top which is touching 8,000. These are the frequency, means count of something. What does it represent? It represents that the minimum value is 2.24 and this number is suppose 7,500. Again, you don't have to go into the depth of that number. If you look at from 2.24 to suppose 7,500, how many values are present in that range? Total 8,000 data points. Can we say this? That 8399 data points are present in this range, $2.24 to 89,000. But if I look at the histogram, it is showing that between this range of values, there are 8,000 data points. After that, after 7,500, there are few data points, but 8,000, which is the most of the data points, are present here. Range of values and how much data is present, that we get to understand. One thing. Second is the distribution. What type of distribution is this? See, Sujata, mainly it is used to represent the distribution, mainly. Okay, and second information it gives us that in which range the values are present. Mainly it is to show us that it is uniform, it is normal distributed or not. So it is basically skewed, as you can see. Skewed. What skewed it is? Right skewed. What it is telling you? What does the right skewed means? Right skewed means that there are some data points in the right side which are basically outliers. Means it is saying that there are a presence of outlier on the right side. This is what your right skewed will tell. Left skewed will tell that in the left side of the data, you have the outliers present. Yes, Sujata, there is a better way. We'll be talking about a density plot, which is much better than that. But histogram is used. It is a very old function, so which is commonly used for that. But there's a better one, which will show you the same. Better. I'll show you.
Yes, sir. Sorry to interrupt.
Yes.
Yes, sir. The line is going from 0 to 40,000 towards the right. What does it mean, sir? Manuel, to understand.
See, look at the sales column. In the sales column, sales is what? The amount at which some product has been sold, right? So now 2.24 is the minimum and 89,000 is the maximum, which means that a person has spent $2.24 minimum and a customer has spent 89,000 as maximum value. And there are a lot of customers between that, or better than that, if you're not understanding sales, let me take the profit. Same thing, let's take a look at the profit. Now see what is about the profit. What is profit showing you? In the profit, you can see there is a building in the middle, which is saying that this company made a profit of this much amount. The minimum profit the company made was this, and the maximum profit the company made is this. But was it a lot of items on which the company made this much of profit? Was it a lot of items on which the company made it this much profit? No. Maybe 1 or 2 products they have sold where they got such a higher profit and such a higher loss. 1 or 2 products. Out of how much? These many. So this particular building is saying that from this point to this point, this building is saying that from this point to this point, the most of the company's profit are in this range of values. If you go on the right side, there are some products which has been sold at this profit rate level. Then there are even less products, even less product. You cannot see any building here, but the building is there. It is basically 1 or 2 values, so you're not able to see that building, but the buildings are there. Okay, so it represents how much data. So it is showing us the count on this, or you know it by the frequency. Count means, see, take this height of the building. Take this height of the building. What is this? It is somewhere around, you can say 100 or 200 maybe. So which means that between this much profit value to this much profit value, there are 100 products such that on those 100 products, the company made a profit between this amount. Okay, 100 products are such that by selling those 100 products, the company made a profit of this much to this much, somewhere between that.
So, sir, because of loss, the building is created on the middle, right, sir?
Yes,
Okay.
because a lot of negatives are also there, a lot of positives are also there. That is why.
Okay.
So is this a normal distribution?
No, sir, it's not.
No. This is not a normal distribution. It is a special type of distribution where we have skewness on this side also and this side also. Both skewness, left and right, both. And this is not normal. Normal histogram will look like this. If it was normal, it will look like this. Okay, and it will be like this. This is a normal distribution, which says that the building size is decreasing with a certain speed. It is not that one building is very high and then all the buildings are very small. That is not normal distribution. Normal distribution says that it is uniform. That is the basic idea.
For sales, there is right skewed distribution, right?
Yes, right skewed.
Okay, okay.
And here we have both left and right skewed both. Which means that basically it says that if you want to remove the outlier from this column, outlier are on the left side also and on the right side also. Both sides. From the both of the sides, we have to remove these.
Hello, sir.
Yes.
So with reference to the existing histogram data, can we conclude saying that the profit margin established is really less? Say, because, for the 20,000 margin, like we don't have any frequencies, there.
Exactly, we can say.
So
exactly.
with this, we can conclude saying that, the profit margin is really on the lower side, right?
Exactly.
Oh.
Yes. So this is a histogram. It does not show you the normal distribution very properly. I'll show you one more function which will show it more properly after a few minutes. But this is just going to show you if buildings is there, one building which is very tall and there is no other building which is of that height. Similar to that, it means that it is skewed. If it is shifted on the left side, if the top building means right skewed is there. If the top building is on the right side, means left skewed is there. And see, the top building is on the middle and a lot of smaller buildings are there. It means that both the sides are there of the histogram. Okay. Yes. Yes, Seaborn also will be studying, not much. The main concept of the histogram and the main concept of visualization we have understood. So Seaborn is easy to understand. Seaborn is much more easy than this matplotlib concept. Okay. Yes. So histogram is going to work on a numerical column, one numerical column, and you will study that numerical column which you want to know about. It is not that any randomly you will pick. So suppose I wanted to know about sales, that in what range of sales that is happening, I want to study that, I can do that. Mainly sales. Then for order quantity, then for profit. So at a time in a histogram, we take only one column, and wherever you're going to see, you will be seeing only one column at a time. Yes, you can do for multiple also, but that is not something you will be doing. That is a stacked histogram, but you will not be doing that. It makes it very difficult to understand. Yes, yes. Okay, so let's take one more break and then we will start our concept of Seaborn. And that will be much easier, much better to understand from this. In the concept of matplotlib, we have written so many functions. All of those functions will be reduced. We will not have to write X label, Y label, title, those many things. That will become very easy to understand in Seaborn. Okay, yes. Now say this has to be in X-axis. This one value I'm taking in X-axis, whatever value. So this X label is my profit per. Y is my frequency. Got it? No. Only one. Only X-axis we give, never give Y-axis. Y-axis will be taken itself. We don't mention the Y here. The profit and sales that we have been taking, both profit and sales, both will be in the X-axis only. One at a time. One time you take profit, one time you take sales, but in the X-axis only, Y-axis always the count of that. Okay, yes. Harish, we can go for a break, and after the break, we'll talk about the Seaborn.
Yeah, sure. So guys, it's time for a short break. Be back in 10 minutes. Shikha Pandey. Yeah, hello everyone. I hope everyone is back from break. Yeah, Shikha, now over to you.
Just yes, I'll share the Jupyter file. No worries. I'll share that. Now we are going to talk about the second package. Whatever we had to do in Matplotlib, these are the basic type of plots you're going to create. And after that, there are some type of plot which you will create with Seaborn, some new type of plots that we are going to talk about now. So when I look at the Seaborn library, Seaborn. Now, what is a Seaborn library? Seaborn, you can say that it is basically a advanced version of Matplotlib. Whatever operations we have seen in Matplotlib, there was some limitations in Matplotlib. First, it cannot handle the complex type of data that we have today. It cannot create any complex type of plots. So there was one limitation. Second was that there are too many functions, too many things I had to write. That was a second thing, that pl2.label, title, so many things, and that becomes very cumbersome to remember. After a certain point, it becomes very difficult to remember. So now we are going to talk about Seaborn, and now we are going to see what plots are created with Seaborn. So the two functions, no, all are not completed. Half of them are completed. Now we are going to see more of them. Boxplot, I will show you with the Seaborn. Boxplot is actually created with the Seaborn, not with the Matplotlib now. Earlier it was created, but Seaborn does it much better than the Matplotlib. So both the libraries, Seaborn plus Matplotlib, you will use them together to create a plot. Together. It will not be like you will be using one as a replacement of the other one, both together. Some of the plots Seaborn can make properly, some of the plots Matplotlib can make properly. And that is what we are going to talk about. Let's get started with Seaborn. Now to use Seaborn, I have to just do import Seaborn as SNS. SNS is the name given to that, the alias name, Seaborn. Now, there is some thing that is given to us in the Seaborn. There is a concept of inbuilt data set. Okay, there is a concept of inbuilt data set that we can use for the learning purpose. Like I have used multiple CSV files for getting different type of data. So here I can read the file from the data that we will do in the real world. But for now, for the learning purpose, to get access to that data, we have some inbuilt data set so that I don't have to take multiple CSV files and read them. So what I'm saying is, when you check sns.get dataset names, sns.get dataset, you will see some names, and these are preloaded data, which is preloaded into the Seaborn. You don't need any CSV files for that. You'll be able to read those data. Now, how to read them? You can see the names are given: Titanic, Tip, Taxis, Planets, Penguins, MPG, Iris, Health Experience. Different things are there. How to read them? To read them, you have to say df is equal to data frame is equal to sns.load dataset. sns.load dataset and say Titanic. And now if you look at it, df.head, you'll see that it is a complete data frame. Complete data frame. Now, what is this? This is a replacement of this. This is a replacement of pd.read CSV Titanic.csv. If you have the Titanic.csv file, that CSV file, if you have, you do this. But for now, I don't have that file. So I'm going to use the inbuilt data set for the learning purpose only for the learning purpose. So load the inbuilt data set, and this load the data set from an external file. Got it? These are the things. You'll understand in few minutes, but just there's a concept of this. Get data set means to see all the preloaded data set, and load data set to load them and to see and to start working on them. Let's start with the first. Let's create the scatter plot. Inside this, we have seen a scatter plot there, but now you see the scatter plot of this one. This will be much better than the previous one. Now see, there is a function which is called a rel plot function. I have to write sns.rel plot. Rel plot means relationship plot. So rel plot is a function which can help me create a scatter plot and a line plot both. One common function, it will help me create a line plot also and a scatter plot also, both of them. Now, when I look at it, to create that, first I need a data. So I'm going to read a data, which is my tips data. I say sns.load data set. And there is a data set by the name of tips. The way it is written, that way you have to write. No .csv, nothing. Just tips is written, write tips. I read that, and then I'm going to check how does it look. Now see, I have got this data. Now what type of information I'm going to plot with this? You know that in a scatter plot, you take two numerical columns and you plot that. Basically, two numerical columns, right? So there are two numerical columns, which is total bill and tip. And the numerical column should be continuous, not like this. 2, 3, 4, not like this. They should be numerical in a continuous format. Remember that. So what we do now, I am going to say my X value will be total bill. Y value will be tip. X could be any one of that. Y could be any one of that. It is just a choice I've taken. X is this, Y is this. Then the third parameter I have to mention is tips. What I'm saying is I have to create a plot by taking this column as my x-axis data, this column data as my y-axis data, and these two columns, this column and this column, is from the tips data frame. Right? From which data frame these columns are? That is what you're mentioning, that from the tips data frame these are. Next, one more thing you have to mention, which is kind is equal to scatter. And let's plot. And you will see plt.show. So plt.show will be used here also to show the plot like this. But when I have created the plot, it does not seem any magical. It does not seem better than what we have seen before in that part. It looks very simple and straightforward. This is because of the reason that it is not a Seaborn style plot. See, there are two things. I said that Seaborn is a updated version of matplotlib. So whatever code was used to create the matplotlib, that same code was taken and made some changes on that to get the Seaborn library. So they both are a kind of similar. And you use them together also. Now, when you use them, there are two styles of plot that you get to see. One is a matplotlib style, and one is a Seaborn style. Seaborn style. The default style of all the plot is set to be matplotlib style. Even if you're making a Seaborn plot, the plot that you're seeing is of this style. Style means the way of look, the visual look of that is of the matplotlib style, even if you're making a Seaborn plot. So how can I see the Seaborn style of the plot? To do that, I have to mention one thing. Just before making a plot, just mention this one thing, sns.set. sns.set means that set the default style of the plot to be of the Seaborn style, not the matplotlib. I've run that code. Now see the difference. Look at it. It is very simple, white background, nothing proper. But now see the difference. As soon as I've converted that to a Seaborn style, it looks much better and much composed as compared to what we have seen before. That is our Seaborn plot. Okay, so to make a scatter plot here, you can use this function and you can create a scatter plot here. But now, are we just doing this to get this? We can do a lot of other modifications which was not possible before. Right? We can do a lot of modification which was not possible before. What sort of modifications can we do? So if you look at it, tips is a data frame. Data frame from which these are the two columns I've taken. Tips is a data frame. Now, so have a look at it. What are the points here? The points are representing one particular row. The dots you're seeing, all of these dots, what they are representing? One row of the data, these 2 points. So it means that if you look at it, there's one customer who has spent this much on total bill, this much on tip, this much on total bill, this much on tip. So we are trying to see here, what is the relationship between a bill and a tip given by the customer? Okay. Now, if you look at this column, there it is mentioned that the first customer is female, second customer is male, then male and female. Customers. Now, can you mention that or can you identify that information from here? That which dot is representing a female customer and which dot is representing a male customer? Can you identify that particular thing? No. It is not possible to identify from here. But what we can do a very interesting thing and we will be able to identify. So I will say hue. And in the hue, I will mention that column which has the male and female category. Now just let me run that. Now see the difference. Okay, see the difference now. No, we don't allow the colors here. The colors will be taken automatically according to the categories which are there. Okay, see. So what is hue here? Hue is there to color the dots based on category. So in this column, there are two categories, male and female. And as you can see, two categories are there. So dots are now colored into two different colors. Blue dots are representing male customers and orange ones are representing female customers. Got it? Now, as you can see that a lot of points are overlapping here. I'm not able to see those points properly. So why not make it more readable? What I will do now, I will mention a call parameter and I'll mention the same column here. Now see, isn't this one much better than the scatter plot you have seen for the matplotlib? Does it have much more functionality? Would you prefer using this over the previous one? Yes. Because it gives you a lot of more information as compared to the previous one. And I can identify it, I can see it in a more beautiful manner. And this is what the scatter plot of the Seaborn is. So Seaborn was just created to identify that whatever drawbacks, whatever limitations were there, how can we overcome those limitations and get more beautiful looking plots, which actually help us understand something. What is this telling you? Now this is telling you that the male customers, how they are behaving, and the female customers, how they are behaving. So as you can see, the female customer dots are in this range, which is saying that more concentrated. And then if you look at this, these are less concentrated. So you can see that the male customer is very random. They don't have any pattern in which they pay the tip. But the female customers are more, you can say, proper, more structured way they pay, more consistent. That is the thing. Okay. This is upon you. Ashutosh, this is upon you, that both the options are taught to you. and you're going to use both of them depending upon what you need at a certain point of time. But since both of these packages are being used, so both are being taught to you. Got it? If you want to use this one, you can use this one. If you want to use that one, you can use that. Now, so the scatter plot we have created. Let's move forward to the second one. We don't have much time left. Let's see now the line plot. Line plot. Now, does anyone know for what type of information do we use a line plot to represent what, basically? Anytime you have seen a line plot. Line plot is used to represent a trend, right? Line plot is used to represent a trend. Remember that. In just one simple statement, if you have to say something, that it represents a trend. But trend of what? A trend that is happening over a period of time. Okay. A trend that is happening over a period of time, that is important to remember. What period of time? So see, the data that you're going to plot with a line plot is going to have one time related information and one numerical. Remember that always you have one column which will be time related and one column which will be numerical. Always this. That is the thing you're going to see with the line plot. You can just open up images and you will observe that on the x-axis you will have month or days of the week or year, something like that will be mentioned on the x-axis, and on the y-axis there will be a numerical value, always like that. So that represents a trend that is happening over a period of 10 years, 20 years, 200 years, 500 years. That is the kind of trend we try to observe. We don't look at a trend for basically 1 day, 2 days. We take a look at 7 days in a week or 10 years or 5 months, some trend like that, which can give us some kind of relationship. Now, to make a line plot, what we do, we say sns.rel plot again. See, there is a line plot function also, but rel plot is much better. What we will do now, we will mention that on my x-axis, the year. On the x-axis in the line plot, you always take that time related information, means days of the week, month, or year. Then on the y-axis, you take the numerical value, which is my passengers, always. And from which data these two columns I'm using? The flight data frame is from which we are using this two. And then I have to mention kind is equal to line to get that. Okay, and then I'll say plt.show. No, it should be working in Colab also. Maybe you have not written the name correctly. Check the names. The names you have to check from this list, sns.getDataset. Okay, that exact name you have to write, not to CSV or nothing like that. Just the names, which is the way they have been mentioned here. Okay, now line plot. What is this representing? Line plot is representing this. It is going in the upward direction. So it is representing that there is a positive trend between year and passengers. So this data is about the flights that was taken by the passengers. So when the flight was started for the first time in 1949, how many people took the flight in United States? Then 1950, 1951, 52, 53, 54, 55. With the increase of year, are the number of passengers increasing or not? That is what a line plot tells you. Okay, that is what line plot tells you. Trend of some sort of adoption. Like if you want to see one more example, you can see that suppose I'm talking about year and number of users of Instagram. Okay, number of users of Instagram. In year, we have 2010, 2011, 2012, 2013, 2014 till 2020. You want to see what was the trend of increase of the users of Instagram, or what was the trend of decrease in the users of some platform. So when you're talking about a trend that is happening over a period of time, one period and one numerical information. Number of users is a numerical value. You take this kind of information and it will be represented by a line going upwards or line coming downwards. Downwards means downward trend and upwards means a positive trend. Perfect. This is the thing. Continue. You can take both of the values. In here, discrete or continuous, both of the things you can take. It should be numerical. That is the both you can take, but it should be numerical. Should I move forward? No. Yes, that is the thing. I said that this matplotlib and Seaborn, they are related. Seaborn is an advanced library of the matplotlib. Matplotlib was created before, but some advancements are done on matplotlib to get the Seaborn. That is why this plt.show is used with Seaborn to print the plot. SNS.show is not there. So they are used together. Since they are same thing, just one with more advancement, one is an older package. That is why we use plt.show here. Got it? Now, okay, so let's have a look at another one, which is my box plot. Box plot. In the box plot, what do we look at? So box plot is used for one numerical versus one category. Okay, one numerical versus one categorical. This is our box plot. Now, so I'm going to take one numerical and one categorical to understand this something. So let's see. I am going to use sns.cat plot, or you can use the box plot also. sns.boxplot. sns.boxplot. In here, what will you mention? One, x is equal to, let's say, time. Time is a categorical column, and y is equal to, let's suppose, total bill, which is a numerical column. One categorical versus one numerical. The categorical part will come on the x-axis, the numerical part will go on the y-axis. That is the way you need to make it. Once you have that, the data is equal to tips. From the tips data frame, you are taking these two columns. Now, plot it. Plot it. Now, what are you observing here? What is the information given to you here? That is the thing. That is the thing we need to understand. I hope you must have studied about the interquartile range concept in statistics. The interquartile range concept is what being represented here. Same, whatever interquartile range was. So this is your minimum. This is your Q1. This is your Q2. And this is your Q3. And this is your maximum. And these are your outliers. So this is not the actual maximum. Actual maximum is this point, the top one. But after removing the outlier, which one is the maximum? That is new maximum, you can say. So minimum, Q1, Q2, Q3, and the maximum. So same thing. I don't need to go into IQR because I think you have studied that in detail. Whatever IQR is, boxplot is showing that. Okay, now, what you need to look at here is the middle value here is the median. Middle value here is called Q2. Q2 is also called median. What does this represent? What does this basically tell you? How do you interpret this information? So it says that when a person comes for lunch versus a person comes for dinner, the person coming for dinner spent higher on an average. Okay, for eating into that restaurant, the person who comes for dinner is spending little bit higher as compared to lunch. So in lunch, this is the average amount being spent by a customer. And for the dinner, this is the average amount spent by a customer. Okay, so dinner one is higher than the lunch. That is the information that we are getting. Again, to know it more about it, you can revise the IQR concept. Whatever IQR has given, that will give you the same thing. Minimum, maximum, Q1, Q2, Q3, same. So why do we actually study this box plot? Box plot is going to give us the information about the outliers if they are present in the data, and what is the median. Is the median for first category higher or the median for second category higher? Whichever is higher, it will tell you that. Okay, yes. Yes, if statistics is something that you are going to forget very easily. So there is one thing I can tell you. How can you remember the theoretical concept? See, once you have studied something today, make sure you revise between 12 to 18 hours. Once. Make sure you go through that particular thing. I have taught something now. Make sure you go through it in 12 to 18 hours at least once. You'll get your time, 5 minutes, 7 minutes, whatever you get. You can go through it because you have studied fresh. You will be able to remember. You don't have to even practice that. If you practice, much better. But even if you get to look at it in the next 12 to 18 hours, much better. Then you look at it in 3 to 4 days. Then one time you look at it after 12 days, somewhere around 12 days, and one after 1 month. Once you do like that, it will take much lesser time as compared to going back after 15 days and revising everything back. That will take much time. But if you follow this pattern, you will be able to remember the topics very easily, and you don't have to waste a lot of time for that because they will be easy to revise. Got it? This is a technique which is going to help you for machine learning a lot and for statistics also. Got it? Now, let's talk about the another plot. Cat plot, box plot we have seen. Let us talk about one called as a reg plot. Okay. I'll take few more minutes of yours, not very long. Few plots are remaining. Let me discuss about that. Something called as a reg plot. Reg plot is basically a regression plot. The regression plot is just nothing but it is an advanced version of scatter plot, where with the scatter plot, you also pass a line through that. Okay, let's see. So TIPS data is there with us. What we will do with this TIPS data, see, I will say SNS dot reg plot. Okay, I'll say SNS dot reg plot. And I will mention here this X is equal to total bill. Same thing which I have mentioned in that scatter plot. Then I'll mention Y is equal to tips. Tip. Then data is equal to tips. Now see the difference. Reg plot is just an advanced version of scatter plot. Okay. So now, what is this? This is basically telling us about the strength or the pattern which we are seeing here. So this line is telling us that what is the strength of the relationship between these two columns. That is what this tells us. So this line is going somewhere here. If it went like that, it would have represented a strong relationship. But if it is not going like that, it is going somewhere here, it represents a weak relationship. And that you can verify also. How do we know it is a weak? the points are very much scattered, since it is a weak relationship. If they were together, like the points are together here, if they have been together here also, then you would have got a line which has went up. That is something you must have observed. Got it? Just write it down. Yes. You can check with the tips.core also between total bill and tip. See, between the total bill and tip, how much is the strength? Just 0.67, which is also telling you the same thing, that the relationship is weak. Just 0.67. It is a pretty average relationship. Got it? Now, let us see an interesting thing. Now, if I try hue here, that will not work. If I try hue is equal to this, won't work. It says that the rect plot does not have hue parameter. For that purpose, if I want to use the hue part with the rect plot, what I will have to do? I will have to use something called as a LM plot. Let me show you what is LM plot. Have a look at it. So I will say SNS.LM plot. And in the LM plot, mention the same things. Okay, exactly same thing. Mention it here. And then say plt.show. See, it is going to make the exact same thing which is being created with the rect plot, exactly same. But what we will be able to do with the LM plot, which is not possible in rect plot, is using the hue. So I will say hue is equal to this. And now see the difference. What extra is happening, you see about that, is one thing, colors are being done, the points are being colored into two different categories, and then for each category, one line is being created. Okay, so it is showing us that which has a stronger pattern. Are male customers following the stronger pattern of paying a tip, or are female customers have a stronger pattern? Now, if I go here, it is not visible very properly. So for that, what I can do, I can say, put that into two different columns. See, it is the rel plot part. If I just change it to rel plot, it will become a scatter plot. And if I put that here, just change from rel plot to LM plot. Now you see, it is the combination of rel plot plus rect plot. Got it? It is a combination of rel plot, basically scatter plot plus regression plot. It is a combination of that. Now, is it much better visible now? That are the male customers more consistent, or are the female customer more consistent, where we have a stronger trend that will be visible to us. So now you can see a little bit, I think, better here as compared to female customers. Maybe, but by looking at it, that is the idea. So I'll give this to both of you. Yeah, so earlier if I said that, then it would be same. Okay, this is telling you more properly which one is more. So whatever it is visible here, that is the same thing which is visible there also. Right? This line is verifying our answers. If the points are more closer, then the line will be going more upward. If the lines are not more closer, then it will not be going upward. So I think they might be both similar. in these cases. There's not much difference between those. This also, this also. Kanchan, you might have written something wrong. Check that. Somewhere, some spelling mistake maybe you might have done. Okay, this is clear to everyone. Just few more plots are remaining, 2, 3 or more are remaining. It will take maybe maximum 10 minutes. So regression plot is this. And if you want to do this, something like this, this is done by the LM plot. And I hope this is clear. Okay. What is this telling you? This line is just verifying our point that whichever is stronger, whichever is weaker relationship, it is just verifying that particular point. After this reg plot, there is LM. I'm forgetting that name. LM is there's a name at that. I'm forgetting that name. So let me show you now a distribution plot. Distribution plot. You can see the name. There is a name for LM. That is what it is. Yes. Distribution. What is distribution? See, distribution is going to show the histogram we were talking about, right? That same thing we will be able to see more properly with the distribution plot. There's a plot for that. Let's have a look at it. Now I have a tips data, same one I will use for this. Tips.head. Now in the tips.head, there are the information. Now what is the thing about distribution? As I said that to check the distribution of the plot, whether it is normal or skewed, we use a histogram one. But there is a better option. What is the better option? Something called as a KDE plot. So I will say SNS.KDE plot, and I will say X is equal to our total bill. And then data is equal to tips. Now take a look at it. I have taken the tips data and I'm just using SNS.KD plot, a very simple small thing. And what is this going to do? No, import matplotlib.pyplot as PLT this. Okay, if you have done now, don't do it now. I'll share the file with you. This is the thing you need to write. See, what does this represent? This is representing the distribution I was talking about of a particular numerical column. The numerical column I have taken here is the total bill. And what is it showing? Is this a normal distribution? And does it look better than what histogram was showing to us? Is it better readable than that? Yes, right? It is better readable as compared to that. And now, whether this is a normal distribution or not, you can say it is almost normal, but not exactly normal. It would have been exactly normal if the curve was somewhere here. This would have been normal. But it is little bit right skewed. And how do you know little bit right skewed? So you see the tail is how longer in this side and the tail is little longer on the right side. Okay, slightly right skewed, slightly. But you can say it is almost normal. And if you remove little bit of outliers, it will become normal. So this is how you check the distribution of any of the data given to you. To find out whether that data is normally distributed or not, you can use the SNS.KD plot for that. Now, if you want to see the histogram, for histogram, there is a function called as SNS.displot. DISPLOT plot. Same thing. Copy it, paste it, and just say plt.show. See the difference between, or see the similarity between them. Now, whatever it is showing by smoothing the curve, it is showing that by making the buildings. It is showing the exact same thing which is shown by that this KD plot, exact same thing. Just it is telling us it with the histograms, multiple histograms.
Sir, can we merge these two plots in a single plot, KD plot and histogram?
You can do that with the that subplot concept. Try that subplot.
Okay.
In that subplot, that plt.plot we have written, right? So at the base of plt.plot, mention one SNS.KD plot and another plt.subplot, mention SNS.displot. Try that. So KD plot, and if you want to merge that, there is an option also, I think. I think KD is equal to true, maybe. Let me check that. To merge it, I have a concept. Yes, this. In a displot function, there is a parameter which is called KD. So when you mention KD is equal to true, by default it was false. By mentioning KD is equal to true, you will see the histogram also, and you will see the curve which is being created according to that histogram. Both the things. So this is much better than using this because this is showing you both the things. Now here, if you yes, this is the thing. If you want to do one more thing, like you are saying KD is equal to true, and if you mention hist is equal to false, hist is equal to false. I think hist is equal to false is not there. Let me see. No, hist parameter is not there. Only KD is there. KD is there. So I'll share this with you. One was KD plot. Got it. Anytime in machine learning or anywhere, if there is a requirement to check the distribution of that, you will be using one of these plots to check the that particular thing. Okay. Now, just last two more plot. One, we have this distribution plot we have seen. Now we have something called as a count plot. If you have any question, let me know, but I think this is clear, simple thing. What is a count plot? So count plot is nothing but representation of that. So suppose I have the TIFF data itself. Rel plot code. Where is rel plot code? Rel plot code I've given very back, long back. Yes, KD means kernel density estimate. Yes. Radhika, which code you want? Okay, so see for now, I will share this complete file. If you have missed something, you can write it. Okay. In few minutes, it will be done. I'll share it. Now the count plot, what we represent in the count plot, for that you need to mention SNS.countplot. And in here, this is basically a bar chart in Seaborn, basically a bar chart. So what do I mention here? I mention here X is equal to this, and then data is equal to this. It's one categorical column. In a histogram, in a KD plot, we were taking one numerical column. Here in the count plot, we are taking one categorical column. And what is this going to represent? Do we have more male customer or do we have more female customers coming to that restaurant? We will be able to compare that with the count plot. So in the count plot, you have to take one categorical column and you have to see the count of it. Very simple and straightforward. Now, let's do something more interesting on this. Like, I want to see the male and female customers who are smokers and how many of them are non-smokers. Okay, so what I will do, I will come here and I will mention hue is equal to smoker. Hue is equal to smoker. And now see the difference. What is happening here? There was one building, there was one bar. That one bar is broken down into two bars, saying that these many male customer, these many are yes and these many are no. Yes, hue. These many are yes and these many are no. These many are yes, these many are no. So
Hello?
the number of female customers, these are broken down into that. Yes.
Hello, can we take X equals to smoker and U equals to sex? Okay.
Yes. I'll take this one. Okay. You're asking how do we know? Okay, 1 minute. I'll tell that. So remember that in hue and col, in both of these parameters, you have to take a categorical column. Categorical text column. In both of this, hue and col. So which columns I can take in hue and col parameter? In hue, I can take these four. All of these four. Because these are four categorical text columns, and these, any of them I can take in hue and col parameter. Okay. Simple thing. Very, very simple. A categorical, which is in the text format, that I take. Okay. So now what is this showing us? So mainly it is showing us how many are smokers and how many are non-smoker. The people who are smokers, out of that, how many are male and how many of them female? The people who are non-smoker, how many male, how many female? So which category is more, which value is more, you can get to understand that with the count. Okay. So remaining few things, just 5 minutes. Okay. Now, I think you must be tired, but just 5 minutes more it will take. Pair plots. Count plot is just this much. It is like a bar chart, and the bar chart you can break down into multiple categories here very easily. That is the thing which you're doing. Now the pair plots. What is a pair plot? So for pair plot, to help you understand about this, I have sns.load dataset. sns.load dataset, and we have what? Iris. And I have iris dot. Okay, see. What will pair plot do? Pair plot is going to create all the possible scatter plots between the numerical columns. So for that purpose, I have to just take sns.pairplot. And in this, I don't have to give any X value, any Y value. I need to give the complete data frame. Complete data frame name and just say show pair plot. Now take a look, it is taking some time. And what is this creating? Many scatter plots that you can see. So have a look at it, what it is going to create. See, if you want to create one scatter plot, you will have to do it 4 or 5 times, but it will create all the possible scatter plot of the data at once. How many scatter plots are possible in this data? If you look at it, 1, 2, 3, 4, 5, and then 6. Right? As you can see, 6 unique scatter plots you can create. If you want to go in the opposite direction, you can create 6 more. That will be 6 duplicates of them. which means that if I am having petal length with petal width, I can also go petal width with petal length. That will be the duplicate of that. Just changing the x to y axis, y to x axis. So 6 unique scatter plots will be created. What will my scatter plot do? My scatter plot, pair plot is going to make all the possible scatter plots here. So see all the 4 numerical columns it is writing here. And all the 4 numerical columns it is writing this side also. Now, you don't have to read these diagonal ones. Why you don't have to read the diagonal ones? Because diagonal ones is a relationship between the same column with the same column. So diagonals have not to be seen. Apart from diagonal, you can see the other ones. Let's see what is this. What is this plot about? This plot is about this petal length in x-axis, and there is no y-axis here. So what is the y-axis value? This. Okay, no, we cannot eliminate the diagonal charts. So mainly that is how they are used to create that. You cannot remove those diagonals. They will be there. But this is just to get an idea. How would you make, why would you make a scatter plot? You know that scatter plot you will create to check what is the relationship between some two columns. So here you can get a relationship about all the columns quickly. That is why you are going to use that. This is a group of scatter plot. Exactly. Yes. So this is like collection all in one plot. If you want to do one by one, you can do that. It is not that you have to use this pair plot. If you want to do separately, sepal length and sepal width, use SNS.rel plot, x is equal to this, y is equal to this, do this. For second, you can do this again. For third, you can do that again. But this is going to give you all the option at once. Means if you want to see multiple scatter plots at the same time, you can see that with the pair plot at this. That is why we. Okay, it is just an option given to you. So if you want to see all the pair scatter plots, that is an option. Okay, and that is what we need to do. And in here also you can use the hue. Hue is equal to, there is only one column, species, which is a categorical text column. So you can give the hue as the species. Now try these all things on. Yes, pair plot only shows pair of scatter plots, only scatter. So when it is going to create scatter plot, you know that is only created on the numerical data. That is why all of these scatter plots are there having the numerical data. The species column will not be included in that. Okay, so last one for today. There is something called as a heat map. The last one. If any of that is remaining, I think I've covered all of that. If anything is remaining, we'll see about that in next session, maybe one or two. But I think this is all. So here what we look at, we will see the correlations. Correct. So suppose I have the iris data and I say correlations of that. Okay, correlations. So now when I look at the iris.correlations, these are the things which are there. No, donut chart, we don't make that. Donut chart, you're not going to ever make it. It was used before, but now it does not exist. You will not see in any of the project that being used. It was giving us a very confusing information. So instead of that, you can use the bar chart and all of that. Now this, the iris.correlation. Now this correlation is what? It shows us how much is the strength of the relationship between two columns. Now, what is something you need to look for? You need to look for the values which are either close to +1, or you need to look for either which are values closer to -1. You need to find that. So here is two numbers, here are two numbers, and here are two numbers. So these are the number which are closer to +1. Do we have any number which is going closer to -1? No. The best we have is -0.4. Okay. Okay, don't do this. Right now. Okay, don't do this, Kavita. Don't do that. It is showing here on the screen, so don't annotate it. Okay, now. So if you look at that, the things which are mentioned here, you basically have to find out what values you in the correlation, you have to find out the values which are closer to plus and -1. Now here are 4 columns only, 4 numerical columns. Suppose if there was 25 numerical columns, so 25 and 25, how many values will be mentioned here? How many those correlations will be mentioned? You can imagine that. Now, will it be easy for you to find out the value in that correlation? So many numbers out of that. Can you find out +1 or -1 values closer to +1, closer to -1? It will be difficult. You can do that, but now you have to find out those values from lot of numbers. So what we can do, we can give this particular thing to heat map to help us for that. Okay, I will take this particular thing and I can put it here. What this will do for me, it will just do pld.show. Now this. Okay, and let me mention something, and not is equal to true. And also let me change the color of that. CMap is equal to purples. Now see, I think the blues will also be easy to understand. Take a look. Now, what is this heat map doing for us? Heat map is just helping us. It is going to help us to find out those higher correlation values, close to +1 and close to -1. What is this? There is a strip. The color strip is there given that. If you want to find out the values which are closer to +1, if you want to find out the values which are closer to +1, you need to find out this dark blue color. Apart from diagonals, you don't have to see the diagonals. Apart from that, where are strong blue colors? Here, 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 and here. Is it becoming easy for you to now find out these numbers? Yes. What is anode? Anode basically means put those numbers here. Right? This number, show that number here, show this number here. That becomes easy. Got it? These are the things. Okay, why diagonal? Diagonal basically is a representation of the same column with the same column. A relationship, a correlation of the same column with the same column, that is the diagonal value. So diagonals we don't have to see. It will always be 1. Apart from diagonal, you need to look at the other values. They will show you the correlations. Got it? Can we not plot them? Which? No. This is the plot. When talking about this correlation, no, we cannot remove that. It will be there. Not possible to remove this. Okay. So what it is telling you that this, what does this mean? It means that the petal length and the sepal length are highly correlated. It means that this value means petal width and petal length, these two columns are highly correlated with each other. When one is changing, other is also changing with that almost always. You know the correlation concept. You know what does correlation tells you? It is showing you the strength of that correlation between two numerical columns. That is the heat. Okay, so heat map is doing what? Heat map is just representing this numerical information in visual information so that you can understand the data more properly. That is what the heat map is doing. Representing this thing in a visual format like this. Okay, so this was the last concept for today.
Hello.
If something is remaining, we'll see that in next. But
Hello.
yes.
Sir, can you conclude which plots are useful for Seaborn and which are for Matplotlib? Means for which we need to use Seaborn and for which we need to use Mat.
Okay, there is no like a point for that. But as you start practicing them, as you start using them in the project, at that time only you will understand these things. There's no such thing that I will say that don't use the scatter plot of the Matplotlib, use of the Seaborn one. That you will get to see once you are going through the project. Once you are working on the actual data set, there you will actually understand which one to use that. There's no point for that because both of them are used and it is totally okay. It is totally your preference.
So based on the
Yes.
customer requirement, we are going to run the code, no sir, in the live environment in the organization.
Yes, not according to the customer. So it is. One minute. Yes. So now it is not according to the customer requirement. The customer requirement is going to be created on the Tableau. To the customer, whenever the client or customer comes for this particular thing, you will not show this code to the customer. This is for a data scientist. The customer might not understand data science. They might not understand Python. So for them, you are going to make these plots on tools like Tableau and Power BI. This is for our understanding. So whichever feels better for us, if it feels that this Seaborn scatter plot is better as compared to the Matplotlib scatter plot, you use that. It is totally upon your preference. It's not that I will prefer this or prefer this. I cannot tell that. So first go through this. And once you are practicing this, once you're going through all the examples, you will get more idea automatically that which one to use in what concept. I have mentioned all of those.
Sir, can you upload this?
Yes.
The documents. What?
So I hope you enjoyed today's session. It was a bit lengthy, but I hope you got the quite good amount of idea about that. Latitude and longitude, I think those are numerical values. You can plot with the scatter plot or line plot also. Okay. Perfect. You can go through them and let me know if you have any doubt in the next session or anything. I think in the next session, you will have your project presentations. You will get a notification regarding. Okay. Thank you all. It was good. It was great. Go through it and practice those concepts. Thank you. Harish, it was all from my side. Ravina, if you have any query, then reach out to the team. Team will tell you that. Okay.
Okay, sir.
Hello,
Yes.
sir.
Yes.
Sir, please share your this Jupyter file. You have shared CSV file.
Oh, 1 minute. Hello. Okay, everyone, please wait for a few minutes. There is an announcement. Wait for a few minutes. And let me share once again. This data. I'm sharing the CSV files also, and there is a data visualization.ipynb that is also I'm sharing. Perfect. So everything is clearly mentioned as we have done it today. You can practice it. You will get a lot more idea about that. But again, don't worry about remembering any of these functions. You will be able to remember that once you start doing this in the project. One minute, wait. Yeah, remembering all the function and names, that's a difficulty. Everyone takes a lot of time to remember these things. So that is why don't worry about remembering this. So this is a document that will be there to help you for most of that. If something is not mentioned here, something extra you are using, because in visualization, you can do a lot of things more than what we have done here, but that will be some time. And whatever extra thing you need to know and apply on the data, you can just do a Google search, simple Google search. If you've forgotten how to make a pie chart, just search on the Google, how to make a pie chart. You'll get multiple examples. Okay, so don't need to even worry about. No, interviews, they will not ask about this, not at all. Hopes will be covered. It will be covered in next week or maybe after the project presentation, but it will be covered. Slides are one. Melt function was not there in the syllabus, but melt, you can see the example. See, so a lot of things we have talked about. If something is not there, you can see that.
Shikhar,
Yes.
sorry to
Yes.
interrupt.
Yes.
So, guys, there is a small announcement. So, as you all know, that next week we will be having mandatory projects, right? So that's but still we have one topic to be covered. So tomorrow we are conducting small session from 6 to 7, okay, in evening. So to complete the leftover agenda, okay, guys. So please try to attend the session tomorrow from 6 to 7, okay. For a 1 hour session will be there. For 1 hour session will be there.
In
6
the
to
morning
9.
or in the evening?
6 to 9. In the evening, sorry to announce. 6 to 9. 6 to 9. So we are conducting for 3 hour session.
So that will be recorded or not?
Yes, it will be recorded.
Okay.
So, okay, guys, I'm repeating it again that you will be having a session tomorrow from 6 to 9, okay, on Monday. So please try to attend the session.
Yes, 6 to 9. Yes.
Yes, 6 to 9. And as you all know that you will be having mandatory projects also for Python, Avinash. Python to complete the incomplete topics, okay? I hope everyone is aware of this.
Hello,
Yes,
Harish.
Sachin, I'll take it tomorrow also.
Hello.
Yes, yes.
You are not allotted any time for the presentation, right? Next week.
Sorry, I have not.
Your Odin school, you are not allotted any time for next week. We have a Python week 4. Python
Yes,
week
yes,
4
yes.
plus. For
Yes.
project presentation, what time?
Yeah. So that from evening 5 p.m. your mandatory project submission link will be open. Okay. So and it will be closing up on 10 a.m. on Sunday. So sorry, let me check the date exactly. It's Friday.
Okay, you are not getting, sir. I will go through the success at Odin School.
Yeah.
Hello, Harish.
So have you got?
Hi, Harish. I just want to ask that I sent it an email with you regarding I want to discuss something on the call. Basically, I'm not able to reach out to you on the call, on the number which you have shared with me. So kindly call me back so that we
Yeah,
can
sure,
discuss.
Ashutosh. I will definitely call you back. So, guys, here I'm announcing again. So, session will be link will be available from 5 p.m. to 28 July 10 a.m. Okay. So, to submit the mandatory projects, you need to submit it before 10 a.m. On 28 July. So, please be aware of this date. And guys, we will be completing all the leftover agenda by tomorrow. Yeah. Okay. So tomorrow you will be having session from 6 to 9. Please try to join the session. So you will be completing all the agendas. Okay, guys.
And
So
Harish,
any question is
if
there?
if
Yeah,
possible,
Prashant.
please increase the time slots for presentation. Like we only get 7 to 8 minutes for presentation, and it's such a big project. We have to explain each and every task. So it would be great if you increase the time for
Yeah.
presentation, like up to 15 minutes.
Yeah, Prashant, sure. I will try to talk to my team. And why? Because there is also a challenging part that you need to cover all the 8 topics within the 7 minutes. So you don't need to explain all the single lines of a code. You just need to uh, like explain only the important topics. That's the thing we need to explain to every student. So that's the reason we have provided only 7 minutes. But
Hello.
yeah, I
This
got
time
your
it is
point. I
10
will-
questions, right? This time it is 10 questions. So we'll need
This time it
time.
is 10 questions. Yeah.
Yeah, more time it is required.
Sure. I will definitely look into this. Thank you for letting me know about this, Sunanda. Yeah, guys, and please, I request everyone, please try to submit the mandatory project. Okay, so this is all be
The mandatory
necessary.
project is in, they have given the question on the for link or how is it?
It's available in your LMS. Sorry, I'm getting disturbance sound from your end, Avinash. I'm putting you on mute.
Hello, Harish.
Yeah, Ashutosh. Yeah, sure.
Yes, I'm not able to find any assignment for second week and third week as well for the advanced Python on the lab subdomain.
Yeah, even me, I'm not able to find out. So
So I am
asked.
connecting, reaching out to from last week.
You need
But
to go for page number 2 and 3.
where?
Means next page you need to search for the next page.
On lab subdomain.
In labs.
Please,
Yes. Okay, Avinash, let me mute you. Okay, so guys, I will explain. So Avinash, you just need to click on next page. When you go to the lab, okay. So in right hand side below, you can see there is next. Go to next page option is there. So
can
there
you
you
show
will,
me if possible?
if possible, wait a minute. I will show you. I'll try to show you. Just give me some time.
Okay. I can see that now. No problem.
Okay. It's very good to know about it. And anything else, guys?
Can you show me once?
Harish,
That would be helpful.
Guys, one by one, please. Yeah, Ashutosh, is it you?
No. Issues is resolved. Basically, I can see that. No problem.
Okay. Ashutosh, so you can unmute yourself. Sorry, mute yourself. And yeah, Rishi, you are saying something.
Yeah, that mandatory project will be available on that LMS in the project section.
Yes. So once you'll go to the LMS, left hand side on the contents, you will see on the week 3. Okay, week 3, click on week 3, 22 and 23rd July. It is written as okay. So on the last, you will see mandatory projects question. Second last, you will see the mandatory project question. And at the end, you will see the option to submit your mandatory projects. Okay. From today 5 p.m. it will be activated. Got it, Rishi? Please give the confirmation.
Hello, Harish.
Yeah, thank you.
Yeah, Sachin. Go ahead.
Yeah, Harish, we have learned a very new concepts, and so I think it would not be fair that we get only 2 to 3 days to submit it. So you should increase your time period for submission of a project, I think.
I'm very sorry, Sachin. It's not
Please
possible.
talk to the team if possible.
And Harish, I just want to raise the same question again with you. Like, is it possible for the freshers to do this task, basically a submit
Of
mental
course,
project? But
Ashutosh. Once
I
you
am,
need
but
to go to the questions once. So
yes,
yes.
agree. But I am a working professional. I'm not able to get enough time to learn and practice all the assignments and the submit a mental project within a 2 or 3 days or 4 days. It is not possible for me. Like, I'm not able to attend the Dow session class as well because it is not like I came from the office uh, after like 8:30 or 9 p.m. So how I'm able to get our classes from like Dow session and submit mentoring project, complete assignment, and as well as learn those things as well.
Ashutosh, I think it's very enough time for all of you because still you have 5 days to complete all the mandatory visits, right? So it's not a
But
very less day.
buddy, I
Yeah.
am pile up from like last week course as well, like what which we have learned last week. I've practiced those things as well. Like a lot of things I have to do because I'm not able to get enough time to learn all the things and practice and submit
Yeah,
time.
Ashutosh, sorry to interrupt, but we will discuss it in call. Okay, I will call you back after the session.
Yes,
Sorry for
I
that.
tried
I
to do
received your
since
mail.
last week, basically.
Yeah. Yesterday I tried to call you, but you were not available. This is not the place to discuss these things. So yeah, we'll go with the next thing. But I will call you and I will try to talk to my team, but because we have already scheduled everything, I think it's not possible to reschedule again. So yeah, I will definitely let them know your query. You all guys are wanting some extra time to get it should be better for you. So you'll be having some extra time to complete your mandatory activities, definitely. So yeah, Tanish, you want to say something?
Sir, please call me back after the session. I'm facing some difficulties. I mailed also you.
Okay, Tanish, sure.
Hi, Harish.
Anyone? Yeah, Sampath.
Yeah, I can see only recordings for this week. Only yesterday recording is there. What about last week recordings?
The recordings are not there. Yeah. Can you upload
because
the recording, the past recordings?
Because I may not understand some topics. I have to go through that. How can I go without the recordings?
It's all there. I think for 15th and 16th you were talking about, right? I
Yes,
just
yes.
opened it now. In my
Yes.
LMS, I can see there are both the recordings are available. So please, on the left-hand side content, you need to check. Okay. And please, Avinash, you should mute yourself because my voice is coming back from your end. Okay. So Sampath, just check it once. Okay.
Yeah. Okay.
Okay. So yeah, guys. So thank you, everyone. Please be aware that you will be having session tomorrow from 6 to 9. Okay. Thank you, Shikhar. Thank you for the wonderful session. So we'll meet tomorrow. Okay, guys. I'm ending the session. Bye, everyone. And please don't forget to give the feedbacks. Sorry, I forgot to announce this, but your feedback is very valuable for us. So 9 and 10 indicates that you are satisfied with the instructor's delivery, and below 9 it indicates that you are not satisfied. Please mention the reason also. So I hope everything is fine. Is there anyone want to ask anything? So you can go ahead. Otherwise, I will. It's good to end the session. Okay, thank you for joining the session, guys. Have a great day ahead.